Good afternoon to everyone. Today we are going to conduct a webinar on data analysis and statistical computing. This webinar is being organized by the Department of Statistics, Institute of Social Sciences, Dr. Bhimrao Ambedkar University, Agra. I consider it a proud privilege to welcome our chief guest, Professor T.C.A. Anand, member of Union Public Service Commission, New Delhi, and former Chief Statistician of India, Ministry of Statistics and Program Implementation, Government of India, who has given his consent to grace the occasion as chief guest despite his busy schedule. I further take the opportunity to welcome our Honorable Vice Chancellor of Dr. Bhimrao Ambedkar University, Agra, Professor Ashok Mittal ji, who has given his consent to preside over the webinar and has spared time from his busy schedule to be present at the webinar. Professor Mittal is a renowned academician, researcher, and he has been a very respected and popular teacher of economics in the Department of Economics at Aligarh Muslim University. On behalf of the Department of Statistics Institute of Social Sciences, and on behalf of the Director, Professor Divakar Khareji, and my colleagues, Professor Meenakshi Srivastava and Professor Vinita Singh ji, I also extend a warm welcome to our distinguished speakers, who are all eminent scientists and are one of the top 10 data analysts, statisticians, and professors in India. Professor S.N. Dwivedi from Department of Biostatistics, All India Institute of Medical Sciences, Professor Vijay Kumar ji, Department of Statistics, Deen Dayal Upadhyay, Gorakhpur University, Gorakhpur, and Professor Suresh Kumar Sharma, Department of Statistics, Punjab University, Chandigarh. They are all nationwide known personalities in the fields of their respective specializations. It is really kind of them to have given their consent to address the webinar. I welcome all the reputed speakers on the panel. I welcome Professor V.K. Saraswati, Director, Institute of Engineering and Technology, who is providing us all technical support for organizing the webinar. I am really excited to welcome our more than 3,400 participants who have registered with us in the webinar from India and abroad. They are all teachers, scientists, researchers, professionals from varied disciplines, behavioral and social sciences, humanities, life and medical sciences, engineering and management, market research, banking, and finance. To connect the participants with the perspective of the webinar, I would refer an interview of Professor C.R. Rao with Professor DeGroote in 1987. This interview was published in Statistical Science, Volume 2, Number 1 in 1987 with the title, A Conversation with Professor C.R. Rao. Professor C.R. Rao referred Professor Mahalanobis, where he very simplistically said that statistics must have a purpose. Don't try to solve problems in mathematical statistics. First, look at the data, see what the problems are, and then develop the appropriate methodology for that kind of data. Professor DeGroote asked him what opinion he has about design of experiments and sample surveys. Professor C.R. Rao answered that these are two great methodologies of statistics. Then he asked what opinion he has about inference. Professor C.R. Rao answered that if data is properly designated, designed, and properly generated, inference is obvious. Same way, Professor R.A. Fisher used to say to his research scholars, including Professor C.R. Rao, that he would not read their research papers unless it has some computation. So all these great statisticians have emphasized that development of statistics rests on data. This justifies the webinar of today. I'll go over to precisely mention that statistics is broadly categorized: one, the theoretical statistics, and other, applied statistics. Theoretical statistics, we deal with mathematical foundations of data analysis, including time series, pattern recognition, classification, parametric and non-parametric inference, information theory, asymptotic approximations, experimental design, causal inference, and all kinds of classical and Bayesian inference. However, applied statistics deals with data analysis, that still deals with data. We are all witnessing that world is becoming more and more data-driven, with endless amount of data to work with. Big companies like Google and Microsoft use data for decision making. In business world, it is called BI, business intelligence. Nowadays, data analysis is so advanced that we use data for fraud detection, risk assessment, customer interaction, web searches, air ticket price determination. We all know it is dynamic, and all these decisions are data driven. We are all sophisticated statistical techniques like big data analysis, data mining, machine learning, artificial intelligence, artificial neural network are used as data analysis tools, and this science has emerged as data science. There are two types of data, one the primary data and other the secondary data. We all know primary data relates to researchers' experiment. Secondary data are generally collected and compiled by governmental agencies like NSSO and published and available on government websites. Not much to say, most of us are aware that data analysis deals with cleaning of data, validation of data, transformation and modeling data to discover useful information hidden in the data for the purpose of research findings and other kind of decision making. Data analysis generally deals with qualitative, quantitative, text analysis, statistical analysis, diagnostic analysis, predictive analysis. Predictive analysis is the one where historical data fits into machine learning models to find critical patterns and trends. Further, this model is applied to current data to predict what happens next. Like multiple analytic methods improve pattern of detection of bank frauds by using machine learning tools and data mining. Prescriptive analysis, we know that data analysis results in terms of accepting the hypothesis. However, real life picture sometimes interfere with such results. In this regard, data mining and data modeling comes in handy. In the light of this specific overview, we will dedicate this webinar to get expert deliberations by our speakers on how experiment be designed, research questions be framed to get refined and meaningful data for inference making in the first technical session. And in the second and third technical sessions, we will discuss the latest researches and their applications in the field of univariate and multivariate data analysis, testing of hypothesis, regression analysis, univariate, multivariate, linear, non-linear, logistic models, one-way, two-way, ANOVA, repeated measures, NCOVA, MCOVA, cluster analysis, exploratory factor analysis, confirmatory factor analysis, structural equation models, discriminant analysis, artificial neural network, and all such kind of things with computing tools and algorithms using software like S, R, and SPSS. Now, to proceed with the webinar, before I request Honorable Vice Chancellor Sir to deliver his inaugural speech, I would call upon the Director of the Institute of Social Sciences, Professor Diwakar Khariji, to introduce Professor Ashok Kumar Mittal ji, Honorable Vice Chancellor Sir. Over to Professor Diwakar Khariji.
Thank you very much, Manoj Srivastava, Head of the Department. Very good afternoon to everyone. Am I audible? आवाज clear है? Am I audible?
Yes, sir. Yes, yes.
Sir.
Am I audible? आवाज clear है?
Sir, you are audible, sir.
Respected Vice Chancellor, Sahab, Professor Ashok Mittal ji, Chief Guest TCA Anand, Professor Manoj Kumar Srivastava, Head Department of Statistics, Co-Convener of Webinar, Professor Manoj Srivastava, Professor Vinita Singh, eminent speakers, Professor Vijay Kumar, Gorakhpur University, Professor S.N. Dwivedi, Professor Suresh Sharma, Professor V.K. Saraswat, and dear participants present in this webinar. Let us introduce to our Honorable Vice Chancellor, Professor Ashok Mittal ji. Professor Ashok Mittal Sahab is the Honorable Vice Chancellor of Dr. Bhimrao Ambedkar, University Agra. He joined on this prestigious position of Vice Chancellor in February 2020. Before joining as Vice Chancellor, he was Professor of Economics since 1998. He was also the chairman of economic department for 2 terms. He has 44 years of teaching and research experience. Now it is my immense pleasure to present his further academic profile. As a matter of fact, his academic profile is very vast. Due to dearth of time, I wish to present his academic achievements in very brief. Professor Ashok Mittal is PhD from Banaras Hindu University, Varanasi. His special area of research includes macroeconomics, public finance, and econometrics. His 60 research papers have been published in various reputed national and international journals. He presented about 50 research papers in various national and international conferences. He is also the author of 2 important books. Number one, Capital Inflow in India and Macroeconomic Analysis. Second one is Economics of Cinema Industry in India, Pricing and Taxation. He also contributed chapters and articles in 6 edited books. Besides this, he has delivered lectures, invited talks, sessions chaired, keynote address, etc. in about 70 national and international conferences and academic programs of high standards. He has also organized refresher courses and conferences. He has won various medals, prizes, awards, fellowships. This is about 8. He was also the visiting fellow professor at National Law University Bhopal and Institute of Social and Economic Change Bangalore. This is a very prestigious institute, and this was established by V.K.R.B. Rao long back. He also remained faculty member of University of Allahabad, BHU, DEI, MD University of Rohilkhand University, and Rohilkhand University Bareilly. He is also like member of various reputed professional bodies. Professor Ashok Mittal sir also remained associated with UPSC examination, UGC on SAP program, SAP committees, State Public Service Commission, etc. This is to be mentioned here that he has worked with eminent economists like Professor D.K. Srivastava, Professor T.V.S. Ram Mohan Rao, and Professor T. Krishna Kumar. Last but not the least, Professor Ashok Mittal sir is BSc Mathematics and Statistics and applied high level of mathematics and statistics in his research. Therefore, in today's webinar, he will remain present not only as Vice Chancellor, but also as a scholar of statistics, which is a great proud for all of us. Thank you. Thank you very much.
Unmute करो
Hello,
श्रीवास्तव.
sir.
Professor Srivastava, please unmute.
Thank you very much, Professor Divakar Kariji. Now I request Honorable Vice Chancellor sir to deliver his speech and inaugural speech. Over to Professor Ashok Kumar Mittal.
सारस्वत साहब देखिए कुछ प्रॉब्लम है, आवाज नहीं आ रही. प्रोफेसर सारस्वत,
ये जो एक्स्ट्रा लोग हो रहे हैं वो हिट कर रहे हैं बार बार, उससे डिस्टरबेंस आ रहा है थोड़ा.
प्रोफेसर सारस्वत.
हाँ यस सर, जो लोग एक्स्ट्रा हो रहे हैं वो हिट कर रहे हैं बार बार, उससे डिस्टरबेंस आ रहा है सर इसमें. जो लोग ज्वाइन नहीं कर पा रहे हैं उनकी वजह से थोड़ी प्रॉब्लम हो रही है सर. हाँ यस.
हेलो.
हाँ वो अभी वही कर रहे हैं सर, उस क्लोज कर रहे हैं इसको. जी सर.
उनको सारस्वत ब्लॉक कर.
From my side, I am unmuted.
From my side, no entry. तो
yes sir.
Professor Saraswat, I am unmuted. Okay. Can you please take them to YouTube interface? Okay, okay. You can take them to YouTube. आप close कर दीजिए. I request Honorable Vice Chancellor Sir to deliver his inaugural speech.
Thank you, Professor Srivastava. Am I audible? Professor Srivastava?
Yes, sir.
Professor
Saraswati,
Srivastava,
am
am I audible?
Yes, sir. You are audible.
Yes, sir. Sir, you are audible, sir. You are audible, sir.
Thank you so much. Thank you so much, Professor Srivastava, for giving me this opportunity. I'm very happy to see that the Department of Statistics, Institute of Social Sciences,
Saraswati
is organizing a webinar on a very important issue,
Saraswati
that
ji,
is
I am
data analysis. Hello, is there any problem? Manoj ji, is there any problem?
yes, sir.
Saraswati,
Sir,
Saraswati,
I request you to kindly.
Professor Saraswati,
Sir,
Yes, sir. Yes, sir.
Sir, audible, sir.
should I
Please deliver your inaugural
sir,
speech.
should I start?
I request Honorable Vice Chancellor to deliver his inaugural speech.
There is a lot of disturbance. There is a break in the voice, perhaps. May I start, Manoj ji? Manoj ji, may I start?
Please,
Saraswati,
please look into this.
Saraswati.
Voice is breaking. Voice is breaking.
मनोज
Everything.
हाँ सर आप स्टार्ट रखिए मनोज सर के यहाँ कुछ प्रॉब्लम है मैं उनको म्यूट करता हूँ बीसी सर आप रखिए अपना स्टार्ट रखिए
Thank you very much for Professor Manoj. Professor T.C. Anand, my very respected teacher, Professor Meenakshi Srivastava, which I am seeing on the screen, Professor Vinita Sen, the director of the Institute, Professor Divakar Khare, the learned speaker, Professor S.N. Dwivedi, Professor Vijay Kumar, and Professor Suresh Kumar, and all the participants, very good afternoon to everybody. It gives me immense pleasure today to see that the Department of Statistics, Institute of Social Sciences is organizing a webinar on a very important topic, that is data analysis and statistical computing. For this, I congratulate Professor Manoj Kumar Srivastava, head of the Department of Statistics, and his esteemed team, including Professor Divakar Khare, Professor Meenakshi Srivastava, and Professor Vinita Sen. This webinar, I'm sure, will serve various purposes. One, academically to emphasize the innovative use of statistics at various steps of research methodology, which is important to drive accurate and dependable evidence to guide policy makers in the respective areas. Second, to fulfill the dream of our esteemed Prime Minister, who again and again emphasizing the need for quality research. Third, encouraging collaborative research activities, and fourth, the optimum use of digital facilities in innovative teaching and utilization during the crisis period like this COVID-19. In the area of the multidisciplinary approach, activities will go long way to encourage quality research at every level. Further, I would like to add that the statisticians and practitioners in the light of present developments and advancement must concentrate on new research possibilities and opening for innovative research in the area of data science and data analysis, since almost all decision making are data driven. Secondly, it seems that in last 10 years, data science and data analysis have emerged as a very advanced science and therefore need our attention to address different research fields, problems, use of sophisticated techniques for solution to such problems. To the advantage of practitioners, maybe it be a big data analysis. Nowadays, lot of work is going on how to manage the large data, and simultaneously then data mining, machine learning models, simulation exercises. All these are the growing branches of economics as well as statistics, where we need a lot of further advancement. Now, it is my pleasure that Professor T.C. Anand, member of the Union Public Service Commission, New Delhi, and former Chief Statistician of India, Ministry of Statistics and Program Implementation, Government of India, has accepted our invitation as chief guest in today's webinar. Actually, sir, I would like to share that I wanted to invite you to Aligarh and Aligarh Muslim University some time back, but that time you were very busy with the Finance Commission. Therefore, we could not make it that time. But since when I heard this, that Srivastava Sahib is organizing this webinar, I don't think any other person can be so suitable for this webinar than you, sir. And this was my really desire to listen you, to have you. Of course, I have interacted with you in Indian Econometric Society conferences a number of times. Recently, year before, I met you in Bombay, and then before that in Agra. So, sir, I was always looking for you. And, sir, it will be out of the place to mention, but I would like to remember my friend, Professor Khan Masood, who is a bridge between two of us. He always talked about you a lot. He shared meetings with you, so that I was very keen to meet you. Of course, we can't meet personally, but I can see you this time, and I'm looking forward when I will visit UPSC. I will meet you personally and pay my regards, sir. Further, his presence in this webinar will give an enthusiasm to our Department of Statistics, since Professor Anand has been the Chief Statistician of the Government of India, and his research contribution and the knowledge would encourage the participants of the webinar. Further, it is my pleasure to say a few words about Professor S.N. Dwivedi from IIMS Delhi, Professor Vijay Kumar, Department of Statistics, Deen Dayal Upadhyay, Gorakhpur University, and Professor Suresh Kumar Sharma, Department of Statistics, Punjab University, Chandigarh, who will be covering various topics in their deliberation. I formally thank the speakers to support for this webinar. Although a webinar for such duration, I remain optimistic about the meaningful use of deliberation. I wish it will at least serve the purpose of sensitizing the covered topics among the participants across the country and from abroad. I'm told that more than 3,400 requests we have received, but I'm sorry we have a limited space at this platform, and we could accommodate only 1,000 participants. Rest, I'm looking for that If Professor Manoj Srivastava Sahab organizes another webinar, we will try to interact with them too. I again thank and congratulate Professor Manoj Kumar Srivastava and his team to plan a webinar on such an important topic. I wish he will be able to plan many such more activities in future. I wish a grand success to the webinar. But before I say thank you, personally, I say that this is because of the lockdown, we are not able to invite you to Agra. As we all know, Agra is a tourist place. So I invite Professor T.C. Anand and all the three renowned resource persons that whenever they pass through Agra or near to Agra, please let us know. We will be trying to welcome you. Please be my guest of the youth, if not the youth. I would like to have you with me and would like to interact personally with you. Sir, please come, at least give me one opportunity and let me show my hospitality to you. Sir, once again, my invitation is there. I'm looking forward. Once this crisis is over and we are able to move around, I would like to invite you at Agra and where you can interact with our faculty members. Thank you so much.
Thank you very much, sir, for your encouraging address. You have given us direction into which we must concentrate for new research possibilities and openings for innovative research. Data analysis and data science have emerged as a very advanced science and therefore need our attention to discuss sophisticated techniques to the advantage of practitioners, may it be big data analysis, data mining, machine learning models, and all kinds of simulation studies and statistical computation. Thank you very much, sir. Now I will introduce our chief guest, Professor T.C.A. Anand. Professor T.C.A. Anand is a member of Union Public Service Commission since January 2019. Earlier, he was professor and head Department of Economics, Delhi School of Economics in University of Delhi. He was Chief Statistician of India and Secretary, Ministry of Statistics and Program Implementation from 2010 to 2018 and Member Secretary, Indian Council of Social Science Research from 2006 to 2009. During this tenure as Chief Statistician of India, first, the Central Statistics Office revised the Indian system of national accounts to base year 2011-12, along with series of Index of Industrial Production, IIP, and Consumer Price Index. Second, the National Sample Survey Organization introduced a new regular survey on employment. Third, cadre structures of both Subordinate Statistical Service and Indian Statistical Service underwent a long overdue review. As Chief Statistician, Professor Anand chaired the 19th International Conference of Labor Statisticians, which recommended introduction of a framework for measuring work along with labor and employment. He co-chaired the Friends of the Chair Group on broader measures of progress for the United Nations Statistical Commission, whose recommendations provided the strategy for developing indicators for measuring the sustainable development goals. He also co-chaired the evaluation of 2011 round of the International Comparison Program, which recommended that the program be made into a regular statistical product under the UNSC. He was a member of the International Expert Advisory Group on Data Revolution set up by the United Nations Secretary General. During Professor Anand's tenure as Member Secretary, ICSSR, the fourth review of ICSR was conducted. Recruitment rules for ISSR staff was reviewed after over 2 decades and regular promotions done. He also steered the research efforts of ICSSR on doing the first baseline survey of minority concentration districts. After Anand received his PhD in economics from Cornell University and his MA in economics from Delhi School of Economics. He was assistant professor in economics at Michigan State University, USA. He returned to India in 1987 to become reader and then professor in Delhi School of Economics. As professor of economics, he introduced the course on law and economics, a new area that he introduced in the MA program. He served as a consultant to the 10th and 11th Finance Commissions, where he helped develop the infrastructure index used by these commissions for their recommendations. His research has covered a wide range of areas, including labor economics, industrial economics, law and econometrics. He has provided valuable inputs in developing a practical model for calculating the net present value of forest land through the Central Empowered Committee, which advises the Honorable Supreme Court on forest-related matters. He has served as a resource person at the National Judiciary Academy, Bhopal, including for the first retreat of Supreme Court judges organized there. Professor Anand has served on expert committees of various ministries and agencies of Government of India, the Reserve Bank of India, the Competition Commission of India, councils and board of several universities, as well as international organizations, including International Labour Organization, ILO, and Asian Development Bank, ADB. Having introduced our chief guest, it is my immense pleasure to invite Professor T.C.A. Anand for his address as chief guest. Over to Professor T.C.A. Anand, sir.
Thank you, Professor Srivastava. I hope you can all hear me. Yeah, okay. Let me start by thanking Professor Ashok Mittal for having invited me to participate in this webinar. I remember his invitation to come to Aligarh, and while I was very keen to visit, unfortunately something kept coming in the way which prevented me from coming to Aligarh. So this is the best we can do under the current circumstances. But I hope once the COVID situation has everybody's help in the UPSC, if any of you are visiting the UPSC to help in any of our committees, you're more than welcome to stop by and meet with me. I'll be very happy to meet you. Let me start by complimenting Professor Srivastava and his team for organizing this webinar on statistical computing. From what I can make out of the program, the seminar has two broad elements. Insofar as the topics being covered in univariate and multivariate statistics, they cover such a wide range of issues that I think the intent is more to give a flavor of different things to people and be able to do a lot more in future webinars which can be organized on more specific themes which may come up. But the second part which is really fascinating about this webinar is its emphasis on also giving an exposure to the various computing possibilities which exist in these areas, and will present the participants with a brief introduction to both R and SPSS. I am very glad that there has been an emphasis paid on introducing people to open source software like R in this webinar, because increasingly, as we are trying to encourage all our research institutes and universities to take greater advantage of all the data which is available, access to computing technology will become a major challenge. Commercial packages will always be a constraint to our scholars in different universities based on availability of funds. But R is one of those things which is available as open source and is freely available to all users. As many Indian statisticians learn to use R, we will create a very large domestic user base which can then help troubleshoot and serve as local experts to scholars who wish to work in this area. So from this viewpoint, I particularly welcome the initiative of Agra University to introduce all the scholars who are participating in this webinar to R. And my own commendation is, if you have access to SPSS, wonderful, because SPSS is a very powerful tool with a very powerful support system available globally and the commercial vendors which are available through SPSS. But for those of you who do not have access to SPSS for commercial reasons, or you don't have access to the sort of resources which would require you to purchase SPSS, R is readily available on the net as open source software, and you can learn to use R on your own and be a resource person to all the students and scholars who come to you. The second thing which I think I would like to touch upon, which is important, is that point which was made by Professor Srivastava and Professor Divakar in their opening remarks, the wide availability of data which is now present in today's systems. It said that we are living in a world of data, and virtually everything which we do generates data. Our access to computers, our access to mobile phone, government records, our own activities, access to programs, events, all of them are major sources of data, and literally everywhere we go, we see huge opportunities with the amount of data that is available. This has also created a very interesting side characteristic, if I may say, that a very large number of people who have a passing knowledge of statistics have become data analysts. You will find today political science, sociology, English literature, any number of disciplines, all of them will be working with data and writing database papers, which is very good at one level. But it poses a challenge for the statistician. The statistician is the only one who has had a formal training in the tools and methods of data analysis. The responsibility of the statistician in a world where everybody is using and making use of data and working with data is to actually play the role of the quality control expert. Whenever we see a paper which has data usage and we want to know whether this has been done correctly or not, we would like to turn to the statistician to tell us, does this make sense? In fact, if you look at my WhatsApp groups, lots of times I get referrals from friends and colleagues who will send me one paper or the other saying somebody has done this using data. Is this a correct use of the techniques which he has done? And our role has therefore become much more as the advisors and quality guarantors to everybody else as to whether people are making the right use of data or not. Because as statisticians, you have the training about the methods, the approaches, what technique is appropriate under what context, when should certain techniques be used, what is the correct approach to use a particular technique. That ground level training in methods and the correct way to use them is what distinguishes a statistician's use of data and everybody else's use of data. So the responsibility of statisticians in today's world, I think, has become much more. The statistician is being confronted with many papers which use data, some very innovatively, some not so innovatively, some carefully, some carelessly. And the role of the fact checker, the person who will say that this is a correct use of data and this is an incorrect use of data, or this is not the appropriate technique to use, or this is not the correct way to have handled it, often devolves on the statistician. So the demand for statisticians under the current context has become enormous. The need for the statisticians, therefore, to be aware of the enormous opportunities with the data revolution has thrown up. Different types of data, different forms of data. Data is now there in all forms. Which type of data is best used for answering which question, when should this be done, when should it not be done, are only answers which a careful statistician can give. So I think to create the community of statisticians and the practice of these webinars will make this knowledge even more widely accessible and will serve as a reference point, because I understand these webinars will also be available on YouTube for you to be able to later refer to scholars and say that, look, at this point was discussed, why don't you go and refer to it in the source which is available. So I'm very glad that this has been done by Agra University, and it will serve as a useful benchmark for all scholars who will access this. The second point which I would like to emphasize is when we are doing all of these techniques, it's also important to pay attention to something which I would repeatedly emphasize in all my statistics classes. Pay attention to where does the data come from, and understand, if you like, the data generating process in order to make the correct use of the technology which is appropriate for that data which is available for you. It is the paying attention to the data generating process and its proper technique and the nature of data which it is being generated from. It is this relationship which makes the difference between good statistical analysis and poor statistical analysis. I'm very glad that the seminar has taken place, and I hope this will not be the last seminar, since this is the first one which you're organizing this week. And in future seminars, you can stay more, if you like, narrowly defined focuses in special areas, maybe targeting separate disciplines as well, because statistics being a service discipline services virtually all areas of science, from natural science to social sciences. Everybody uses statistics, and it may be necessary to tailor programs specifically to different types of statistical uses which are possible in the field. So thank you all. Thank you for listening to me.
Thank you very much, Professor Anand, sir. We and the participants, we as a department and all participants have heard you very carefully, and it is a benchmark for us, a guidelines for us. We will imbibe whatever you have said in our teaching and courses, and also we will keep on organizing such webinars for computations where open source software such as R are available. Thank you very much, sir, for your kind words. Now I would request the Director of Institute of Social Sciences, Professor Diwakar Khareji, to say words of thanks to Professor DCA Anand, sir, for he has accepted us as a chief guest. Maybe he have some other engagements. So, Professor Diwakar Khareji.
Voice.
Professor Diwakar Khareji.
Am I audible? I am Avaz clear? Respected Vice Chancellor sir, TCS Anand ji, and other persons present in the seminar. Our learned Vice Chancellor delivered a very thoughtful inaugural address. He talked about quality of research, big data, data mining, etc. And our chief guest, TCS Anand, also delivered a lecture, and he is very eminent person, and he is member of UPSC, ex-chief statistician, etc. And he is very busy person, but he accepted our invitation and delivered a very wonderful lecture in this webinar. He told about the importance of data and also told about the role of a good statistician. He told about the various softwares like SPSS, etc. But he told that these are very costly. So he encouraged to use R, which is free. And his lecture is very useful. And he told about the use of new technology. How? Because we live in the world of data, and this is data revolution, and data must be unbiased and reliable. This is very important, because if the data is not reliable and not unbiased, then we will not be able to draw valid conclusions. So he raised very important questions, and I hope that these questions will be very useful for the persons who are attending this webinar. And now I am extremely thankful to our eminent chief guest, PCA Anand Saab. Thank you very much.
Thank you very much, Professor Diwakar Khareji. Now I will quickly start the technical session of the webinar. I would invite the first speaker, Professor S.N. Dwivedi, to deliver his talk. Professor Dwivedi is a professor in the Department of Biostatistics and adjunct faculty of Clinical Epidemiology Unit, All India Institute of Medical Sciences, New Delhi. Professor Dwivedi completed his higher studies and has done his PhD in statistics from Banaras Hindu University. He worked as researcher scientist at a very higher position at Bhopal Gas Disaster Research Institute, presently known as National Institute for Research in Environmental Health, Bhopal. He has contributed innovative research in the field of epidemiology, biostatistics, randomized controlled trials, systematic review, and meta-analysis epidemiological modeling with a focus on cancer, drug abuse, stroke. He has been lecturing in India and abroad as visiting professor. Gothenburg School of Public Health, Sweden, College of Medicine, St. George's University, Granada, and many other universities abroad. He gave invited address at research seminar at Department of Biostatistics, University of Buffalo, USA. Dr. Dwivedi has been guiding PhD students not only in biostatistics, but he has also co-guided various PhD students in other disciplines like medical sciences. He has also associated with research activities at Center for Integrated Medicine and Research, All India Institute of Medical Sciences. In addition to his various methodological research projects of clinical and public health importance, he keeps collaborating with clinicians in large-scale community projects, presently co-investigator biostatistics for the All India Institute of Medical Sciences cohort study under Indo-Dutch project collaboration. He has more than 200 research publications. He has been serving as external examiner for PhD and master's degree at various research institutes, universities, and he has recently jointly authored a book, jointly authored a book, Medical Statistics Principles and Methods. Further, he has been serving as editor, member of editor committees, the review of national international journals, including Biostatistics, JRSSP, Statistics in Medicine. He has been serving as chair, co-chair, member of various committees at All India Institute of Medical Sciences, committee to assess the need of establishing a School of Public Health, Ethics Committee, Committee for Intramural Funding, Selection Committees, and ICMR, DHR, Ministries, Project Advisory, Project Reviews, Task Force, and many such advisory committees and scientific committees. He is member and life member of various national, international societies, including Royal Statistical Society, very famous one, International Statistical Institute, International Clinical Epidemiology Network, International Society for Clinical Biostatistics, International Epidemiological Association, and International Biometric Society. He has various awards to his credit. He has been a WHO Fellow. He is elected Fellow of Indian Society for Medical Statistics and has been helping the society in various capacities. He is elected member of International Statistical Institute. Professor Dwivedi is presently founder vice president of the Society of Evidence-Based Healthcare India. He has made multiple academic visits to many of the countries like USA, UK, Canada, Australia, Japan, China, Korea, Thailand, and many other countries. I very humbly invite Professor S.N. Dwivedi ji to deliver his talk on statistical tools under planning of a research study. Over to Professor Dwivedi.
Thank you very much, Professor Srivastava.
Professor Dwivedi, if you want to share your presentation.
Yes, I want to, because PPT use will be must to make it more objective. So,
okay, sir. Abhi,
so there is a
so just click on show screen.
From the top, it is fourth option. First, second, third, and fourth option.
Yes, sir, your screen is visible to us.
it is visible.
So
That is okay.
Sir, it is visible.
oh, yes, sir. Okay.
Sir.
So I would like to formally thank Professor Manoj Kumar Srivastava, head of the Department of Statistics at this institution, and his colleague, basically Professor Meenakshi Srivastava, to give me this opportunity to speak to this esteemed audience across the country. The topic, when I got the choice which topic I should be speak to such audience, keeping in view of the mix of the audience from different areas, I prefer to speak on the how to proceed on the specific steps to carry out a research study. And that is how I am going to speak on the various steps involved under planning and carrying out the research study. The focus of this lecture will be basically on the research hypothesis, study design, level of confidence, power of the study, minimum required sample size, analytical exploration and reporting of findings. To begin with, to plan any study in any area, the basic requirement is to do the extensive review of the literature on the topic, go through the related selected articles, and then come out with what literature has on this specific topic in which we are looking into. And this is where the base of the planning of the research rests in. And for that purpose, we have to list out the lacunae in the available literature. And that lacunae, as a researcher, I can tell you that we can take into account non-availability of the studies as such, neither globally nor Indian. And from there, we can start on the inappropriateness of the used data, inappropriate used statistical methodologies, problems related to generalizability of findings, and problems of utility of available findings. The next step comes, very important question comes, what is the research question? And to make the life easier for the researcher, broadly we have two types of research questions. In statistical terminology, one is the estimation and another is the testing of hypothesis. Like I would prefer to give the example from the medical field. Like many a time we come across the areas where there is no availability on the data related to the burden of the specific disease, for example. And that disease indices, generally we use it the prevalence and incidence of the disease. And we all should know that the prevalence is not a rate. Incidence is a rate because generally the data comes out of the prospective studies. And second broad objective might be testing the hypothesis, means you are treating the disease people, for example, whether the drug or intervention is going to be useful or not. So these two broader categories, the whole planning of the study takes place. And to plan the study, we start with the consideration of what is the primary objective of the study. And primary objective is the only point which involves, which helps or which guides the planning of that specific study. Secondary objective are simply part of the primary objective which takes care under the ongoing studies. Now, each study may be pilot, each study may be conclusive, and as a researcher I can tell, in my opinion, a study might be conclusive only if every step of the research methodology is specifically related to the required minimum sample size to answer that research question is taken care of. If we are deviating from the required minimum sample size, our study will go in the category of pilot study, and any finding what we get, it doesn't allow us to conclude. Rather, we have to speak in terms of the suggestive findings. This study suggests this study indicates this, like that. And to clear the myth in the mind of the researcher, I would like to mention here, the study in the pilot category doesn't stop you to publish in the international journal or the quality journals. These days, we have to be, as our chief guest, Professor Anant mentioned, we have to dive for the quality of the data, how the design of the study, and this is what I'm going to take you across during this available time. Now, under a specific hypothesis of the study, for example, in public health, generally we go on the hypothesis. And hypothesis means generally it is related to the welfare program. And let us say we have got an intervention program which might be helpful in relation to the specific area of the public health, and we want to assess whether it is effective or not. So to begin with, we all statisticians, we know, generally we go for the superiority hypothesis, means non-intervention program, intervention program is not effective. That is our null hypothesis. But hypothesis of the study, generally we have to list that this intervention might be effective to deal with this public health topic. I think that is the issue we have to emphasize. And for a statistician, null hypothesis always is about the equality, means effectiveness under the proposed intervention, and in comparison to non-intervention, whatever outcome we are dealing with, it is going to be comparable. That is null hypothesis as usual. An alternative hypothesis, which is nothing but our objective of the study, hypothesis of the study, that is inequality. They are not comparable, means the group which has got the intervention behaves differently than the group which has not got the intervention program. So I think that is the issue. That is one type of hypothesis involved in planning of the study. Another hypothesis is generally in public health is non-inferiority. Non-inferiority means an intervention might be non-inferior. Even if you give this, it is going to be inferior in terms of the standard treatment. Now, issue here is what is the threshold? Means what difference we will consider to say that the newly planned intervention is non-inferior. That is the basic issue, and that has to be guided by the clinician and public health researcher. For example, a drug is giving you 20% cure rate in your standard treatment, and under newly developed intervention or drug, we are getting only 15%. But because we are happy with the cost of the drug, we are happy in terms of the side effect of the drug, we may presume that this new drug is non-inferior to the standard one with the threshold of 5%, means even if cure rate is 5% less under the proposed intervention, I would like to consider this new intervention, new drug, as non-inferior to the standard drug. So that is another hypothesis we can consider in our research study. The next is the non-superiority, which is nothing but the other part of the non-inferiority, and we can very well define, and generally we conduct the non-inferiority trial in drug development. And in drug development, conducting the non-inferiority trial is the best one to start with, and then we can proceed for the better option. Or sometimes people prefer to conduct the equivalence trial, which covers the both arms. Means 5% this way and 5% the other way. Difference between the cure rate between the two arms. If it belongs to the given range, we can call that the both drugs are equivalent. So these are the major hypotheses, statistical issues involved in planning of the research question and research study. Now, another very important issue comes is desired design of the study. Now, which design we need to answer a specific question? I think that is the issue generally people avoid. In medical field, we take care of, but generally I have seen across the universities, generally we become very casual. We want to conduct a study, we go on the collecting the data and analyze it and report it without being very, very specific of what study design, use one design. But if you want to assess the efficacy of the drug, we need to consider the other study design, and that I would like to emphasize briefly here. To estimate the burden of the disease, the study design known as the cross-sectional study, and very simple explanation for this design is data on the exposure variable and outcome variable and other covariates we collect as prevailing on the day of data collection. Like if I come to you, I'm simply asking what symptomatic morbidity you have, and then are you a smoker or not? Do you do physical activity or not? And likewise, but this is as prevailing on the day of data collection. There is no order between the smoking and your symptomatic morbidity. I think that is the basic difference, and that is why cross-sectional study is considered the poor study design as such in terms of the directionality between smoking and your morbidity. But point we have to realize that this is the design which is optimally used in across the country in all departments, in all universities. Means those population centers, the economics department, sociology department, whatever studies we do it, mainly we use the cross-sectional study. But my emphasis is, if we are using the cross-sectional study, we are not aware about, for example, the direction between its smoking and disease. When one started smoking, when one started the physical activity, and what is the disease status today. I think that is the point. It will be more clear if we consider this slide. Here, if you see, we are starting the study once everything has happened, and best example is the Bhopal gas disaster. And I think thanks to Professor Manoj Srivastava, he introduced me, including my experiences at Bhopal gas disaster research center. Study was started once everything happened. But what was the study design for data collection? Data collection was started from the exposure to the gas first. Were you in Bhopal? Were you sleeping inside, outside house? How did you hear about the gas exposure, the leak, and what mode you used to run away? All those things, the data relates to the exposure. Exposure means exposure to the leak of gas, and then what all problems they developed in acute phase. This data is already published, full volume of the IGMR, full volume, special volume on the Bhopal studies. If some of you are interested, you can refer that. I think year 86 or 87, 1986 or 87. But this design, because we are starting the study later on, once exposure and outcome both have happened, they are known as the historical cohort, and best example is the Bhopal study. But many a time, like our PG students, they do the study using the other way. We go on the backward retrospective. Backward retrospective means first we see the disease status, and we take the diseased people and the non-diseased people, and then you go retrospectively to ask, are you a smoker? Since how long? And on an average, how much you smoke? This example I have taken to make the life easier for the audience. It is very simple to understand. Because when one started smoking, that makes sense. Somebody is a smoker for last 20 years. Somebody is a smoker just for last 20 months. Somebody is a smoker for last 20 days. It makes a big sense. And that is how the relationship between smoking and your disease status will rely on the duration of the exposure to that particular phenomena. Same with physical activity. So physical activity will go for protection. The smoking will go for the deterioration of the health. I think we all know. And it is very simple to conceptualize the ideas. So this second part is known as the case control design. And generally, I should mention here, people get confused between case control design and the comparative cross-sectional studies. I keep seeing this. You have got a disease group, you have got a non-disease group, and you are collecting all information as prevailing on the data of data collection. Because you have taken a group of diseased people, you start calling it case control design. It is never. Because whenever we review the study proposal and research protocol, we come across this kind of problem. You can call a study as case control study only if you have used this intervention design. Means you have taken the disease status of the patient, and then retrospectively you are collecting data on the exposure along with the other covariates. What is the difference between exposure and other covariates? We have to be very clear why I am using this terminology, because many of you might have not heard for the first time you are hearing, if you are not from the hospital setup or the public health setup. Exposure variable means in which we are interested. We want to assess association between smoking and coronary heart disease or any disease, means smoking is exposure variable. If we are interested in relationship between drinking and disease status, drinking will become the exposure variable. Just to differentiate among the series of the covariates, we use this terminology, because ultimately after adjustment in relation to all covariates, we want to see how this smoking is associated with disease status. I think that is the differentiation we have to understand. Now, forward prospective design, if you talk about, we start the study in the beginning, we expose the people from the intervention what we want to give. This is the basic difference. Like if you want to treat the people, you are going to give drug, but at the same time, you cannot make the people to smoke. And that is why studies on smoking and its association doesn't fall in this category prospective cohort, because understand, we cannot make the people to smoke. Only thing is we can differentiate between smokers and non-smokers and then follow up them for a long time. So I think we have to be very clear. If prospective design is being used, we can call it prospective cohort, and randomized control trial is nothing but the prospective cohort, because only difference is that the intervention is under the control of the investigator, under the control of our hand, because we are researcher, we have to decide through randomization who will get the intervention, who will get this drug or not. I think that is the issue. Many times in community-based study, we start using the terminology case control nested in cohort. Here you need not to be very. Only issue here is we are conducting prospective cohort, but to analyze the data, we are using the case control approach. That is the basic difference. And why do we use the case control design for analysis once we are doing the prospective cohort? Answer is very simple. We have planned the cohort study, but disease is so rare that taking the sufficient events will take a long time. Like cancer study, if you plan, you need decades to have the sufficient events. So to answer the queries raised by the policy planner like ministry, we can go for this kind of alternative methodologies available for analyzing the data and to answer, to explore the possible answer to the question raised by the policy planner. That is the basic difference. We have to understand. And under trial, this is the standard 2-arm example. We can go for more than 2-arm. Like bioassay, the pharmacological study we do, we have got 6-7 arms you can have, depending on the disease potency. Just to explain the concept, this is how the study falls. But remember, what is the role of a statistician? This is what we need to appreciate. Why I have told that at every step, statisticians' role is there while planning the study. This is what we need to appreciate. Nobody else will appreciate your role. And what is the role here? If we are planning randomized control trial, that until unless you randomly allocate the patient into arms of the study, 2 arms, 3 arms, 4 arms, whatever we are dealing with, each study will not be called randomized control trial. But problem is, do we understand the meaning of randomization? This is a big topic, but to tell you the brief meaning, generally people think that I have generated with the help of computer the allocation sequence, that is randomization. That is not randomization. This involves 2 components. One is to generate unpredictable allocation sequence with the help of the programs, and then plan to maintain concealment. Even if we are doing the open trial, we are not going to blind anyone, neither the investigator nor the patient nor a statistician. Even if it is open trial, we need to maintain concealment. Then only we can call we have done randomization. Otherwise, we have not done randomization. Just it is, we are using as an English language. And I would always emphasize these kind of points while making this presentation, that until unless we have done strict randomization, we cannot claim that we have done the randomization, because this has a meaning. So to summarize the study design quickly, I think time will run fast. I have to go, so many slides are there. This is how we have to differentiate. What is the difference between intervention and non-intervention? If intervention is in the hand of the investigator, then only it will be known as intervention study. And then, as I told you, if you have done the random allocation, then only we can call it randomized control trial. If it is not, then we have to call it the non-randomized control trial, like clinicians keep giving doses as per their choice, and you have got that kind of data. We cannot call that as a randomized control trial. We have to call it non-randomized control trial. And if intervention is not under the control of the investigator, all those studies are called broadly observational studies. And if comparison group is involved, we call it the analytical study. And if comparison group is not involved, we call it simply descriptive study. Many of our PG students do descriptive study. We take a patient from a specific OPD and wards and clinic, and simply we describe them. That is what the descriptive study. We are no more interested to compare with the given comparator. I think that is the basic difference. And as I already showed you the slide related to cohort study, case control study, and cross-sectional study, always take care of the directionality between exposure and outcome, smoking and coronary heart disease, for example. I think this is what we have to always remember. Now, next step comes, we need to be clear about our study population. Now, issue here is, in the community-based study level, we know it, country, state, district, but in hospital-based also, we have to be very clear which disease status we are going to include in our trial, for example. That makes a big difference. Like at All India Institute of Medical Sciences, 80% of the cancer cases come at the stage 4. Might not equally be effective for otherwise, and vice versa. So those issues we have to be very clear that what is our study population, because ultimate goal of doing the study is what? In the end of the study, whatever recommendation we come out, it needs to be generalizable in our study population. So randomized trial, I am taking always example because it will give you the more emphasis that is how to go on. Sometimes people become more selective. I will take this age group and that age group. A drug tested among only adults cannot be appropriate for children and vice versa. A drug tested only for one of the genders, male and female, cannot be applicable in the other one blindly until unless we test it. So this decision and the research design, we have to be very clear. In the start of the study, we have to be very clear what all information we need to collect. Outcome variable, one outcome or more than one outcome, be very clear at the planning stage. This is, for example, hypertension and coronary heart disease or only coronary heart disease. Exposure variable, you are collecting data on smoking or drinking, both you are interested. But under the potential quantitative and qualitative covariates, we need not to miss important covariates. Like you plan a study to see the association between smoking and coronary heart disease, and if you don't collect the data on drinking, our study will be of no use. Simply people will not accept our finding. People will argue that relationship might have confounded because of the variable drinking which you have not collected, you have not adjusted. So this is the simplest example to conceptualize the ideas. The message is what? We need to collect data on each and every covariate which might influence the outcome directly or indirectly. And until unless we become very serious at the planning stage, we will miss the track. So now, to explain that concept, for example, in public health, any association between exposure and disease status we work out, first question we need to ask as a researcher, whatever relationship we have measured, is it because of the bias? Bias means our methodology is questionable, our sampling methodology is questionable, our instruments used for data collection is questionable, the steps written in the protocol to collect data is deviated, who was supposed to collect data, he has not collected the data, rather some instead of the doctor, the technician have collected data. Those questions we need to answer at the first stage, and we have to come with no. If our data is full of biases, the only decorating the analysis with the help of the statistical packages have no much meaning, because only that is ornament. You will talk about all high having nothing, means our data have no strength to speak about any conclusive statement. So ultimate goal is what? Our quality data. That is what I mean to emphasize. And more or less certainly we will say that we have controlled the bias in our data set, and answer if it is no, then question comes, could it be due to confounding or effect modification? Now confounding and effect modification, for those who have not heard, because this audience across the country is mixed, I would like to tell you, confounder means a variable, a third variable, which might influence the relationship between your exposure variable and the disease status. This is confounder. But effect modification is what? If you keep changing the level of the third variable, like drinking is the best example, you take those group of people who don't drink at all. You take those group of people who drink mildly. You take those group of people who drink moderately, and those who drink very badly, starting from morning to midnight. If you make 4 data, and then you work out the relationship between smoking and coronary heart disease, for example, and in association, label is varying from non-drinkers to the severe drinkers, means association becomes more serious. Means those who are drinkers, among them relationship between smoking and coronary heart disease becomes very high. In this situation, increasing role, we have to say what? We have to simply say that the drinking is the effect modifier for the relationship between smoking and coronary heart disease. I hope I have made your life simpler. Very simple. If it is changing. If it is not changing, that is not an effect modifier. I think this is what we have to understand. Now, if we say we have got data on all confounders and effect modifiers, then only answer will be no. And then whatever statistical test we do, and we calculate the p-value level of significance, that has meaning. If we have incomplete data, if we have questionable categorization of the variable, if we have the inaccurate data, only statistical significance does not have much relevance, specifically in public health program. So I think we have to be very clear that we need a quality data. We have to be very clear what was the research question, what study design we have used it, and then you go on considering the scale of measurement and then come on the p-value. And certainly there is another term, causality. That is a separate topic. There is no time to elaborate on this issue. Only statistical significance doesn't allow to conclude that this is a causal factor. There might be many more factors which might be contributing to the coronary heart disease. So I think this is what we have to understand. Now, another very important question in the planning of the study is what? That planning of the study includes that what should be the minimum sample size? And generally, the question is what? We have to be very clear. What is the meaning of a small sample size? What is the meaning of minimum sample size? What is the meaning of large sample size? And generally, I would simply tell you, to answer our research question, we need a minimum sample size, which is explored or calculated considering few of the statistical inputs, so that we are in position to answer our research question meaningfully. That is what is it is minimum sample size. If we increase the minimum sample size, then only we can move towards larger sample size. Generally, people get confused between small sample size and minimum sample size. If we are not in position to cover the required calculated minimum sample size, our study is considering a small sample size, and what implication it will have? Power of the study will go down, and we might conclude, but misinterpretation of the data takes place, that the new drug is as effective as the standard one. I will come on that issue quickly to make it more clear. So I think message for me is, if we want to conclude the study, we go for always planning the minimum sample size. And if consideration of that sample size is not possible, like for our PG student, we should not be shy to say that our study is pilot study, preliminary study, which will create the preliminary evidence on the topic, and we can use that data and to plan the conclusive study later on. So under the minimum sample size, this is how we move. What is primary objective? Under primary objective, what are the primary outcomes? And under this, we need to consider data on the primary outcome to calculate the sample size. Depending on whether our outcome is quantitative or qualitative, we can consider mean, standard deviation, and proportion. And accordingly, another component under sample size exploration is effect size. Like if you take the randomized control trial, means comparison of intervention, means what gain we need to expect. 10% gain out of intervention, 20% gain, that has to be decided while calculating the minimum sample size. And then another issue comes, what should be level of confidence and power of the study? Let me tell you, many of statisticians, we also get confused many a time. We think that the power of the study and level of confidence, they are same, but they are not same. We have to be very clear. And this is the simplest example. In the true reality is what? Whether new drug is effective, means null hypothesis, or new drug is non-effective, that is null hypothesis, and new drug is effective, that is alternative hypothesis. And based on the study, what we conclude, we either say that the drug is effective, or we say that the drug is not effective. Now, for clinician, for applied people, statistical terminology is not appreciated. Like if you say null hypothesis, alternative hypothesis, reject the null hypothesis, when null hypothesis is true, we need to understand in terms of literal meaning. Means what is meaning of level of significance? Very simple. You take this first row and first column, because these two may not be true at a given time. In existing reality, either this will be true, either drug will not be effective, or this drug will be effective. We have to be very clear. So under this situation, either we may conclude that the drug is effective or drug is not effective. If a drug is not effective, we are concluding for that when drug is not effective, this is correct decision. And this is known as level of confidence. So means what is literal meaning of level of confidence? Probability or chance of correctly concluding that drug is not effective. This is what we have to understand. Same way, what is power? Probability of correctly concluding that the drug is effective. Means this first row and first column, the second column. So now, to calculate sample size for the testing of hypothesis, whether it is randomized control trial or the other study design, these both components become part of the formula. We always consider what is level of confidence, what is power of the study to calculate the sample size. Along with that, proportion of the disease status, P1 and P2 into two groups. But once our objective is to calculate sample size for conducting the study on the prevalence, there is no involvement of the power. And you might get surprised why. An answer is very simple. Because under the studies involving the burden estimate, prevalence of the disease, we don't want to take a chance otherwise. We want to estimate which is closer to the population estimate. Means if you want to do a study in Delhi, the prevalence of the malaria in Delhi, whatever it is prevailing, our estimate based on the study conducted in South Delhi should be closer to. Not much deviation. That is the meaning. And that is why power of the study is not part of the sample size exploration. We only take the level of confidence. If you remember, those who are a statistician, you can remember Z square 4PQ divided by D square. 4PQ, 4 means normal deviation square 1.96 at 95% level you are taking, and that gives you. But one need not to worry about formula, those who are non-statistician in the audience. Only we have to understand the basic principle. Why statistical, how statistical principles can be optimally utilized at various steps of the study design. That is what the topic is. And these all components need to be literally understood, because if you understand very clearly, I will be much more happy. And I would like to tell you before I move this slide that what is the meaning of level of significance. Generally, people go with a myth that the level of significance doesn't matter. If we take 20%, 30% and our sample size gets reduced, no problem. But remember, this is a level of error we are allowing at the planning stage. Literal meaning of level of significance is a probability or chance of incorrectly concluding that the drug is effective. Means error. And this error, if you are allowing at the planning stage, it will be a problem. Much error, broader width of the confidence interval estimate. Once you will complete the study, your interval estimate will be very, very huge width, and it is as bad as not conducting the study. So I think message is that we should keep it optimal. Means if you are doing the observational study up to 5% fine, but if you are doing the randomized control trial, even I would prefer you make it more smaller, 1 per 1,000, 1 per 100,000, because that will make your drug, whatever finding you get, it will be for a longer time. Otherwise, there will be problem in future. Now, need of the sampling methodology. If it is observational study, certainly it is a major area. But even in the trial, if we are taking patient from hospital setup, question comes: are we including each and every patient who are fulfilling the inclusion criteria available at our setup in the study? And generally, if it is answer is no, then question come: how are we picking up? Like PG students generally take the patients the day they are posted at a given OPD or clinic. And generally they start writing that the patients were randomly selected. That is what I hate. Always one should write how did we do the study. Means you have done the data collection on the day of your posting, you should write that in a week I have got 2 days posting on Tuesday and Friday, and on that day even I will not be in position to cover every patient, and I have selected as per my choice, purpose 3-4 patients in every day. This is the point I wanted to make out of this slide. Means we need to write the way study was done. And if feasibility is there, random selection is possible. I always prefer to go for a random selection of the sampling unit. If we are doing purposive sampling, we should not feel shy to say so, because people will be aware about the limitation of our finding, and this finding can be used only for the planning of the future studies. Now, if randomization is involved, if you are doing the randomized control trial, like many times we do the phase 2 trial, small level study, certainly we should learn which simple randomization, block randomization, stratified randomization. We have to be very clear, depending on the topic. Like we have done a couple of trials where we have used the stratified randomization, but certainly equal allocation was not possible. Because of the high dose and the lower dose, we went on the unequal allocation. Statisticians know it very well. What are these? Those who are non-statistician, always I will encourage, I will advise that this area is for the multidisciplinary approach. Always make your multidisciplinary team so that your study gets strengthened and you are able to do a well-planned study which has got the findings which can be there, maybe stable for a longer time. Otherwise, believe me, even drug testing, today you are using some drug, within a year that drug disappears from the market and we get surprised. What is the surprise? There is no surprise, because side effects came, that was noticed, and study drug was stopped from the market. So same applies on the observational study. The whatever we have done it, we have to be very clear how did we do it and how did we go on this. Now, whole standard operating procedure for the data collection should start. After you have planned everything, design of the necessary questionnaire, testing, validation, interview, all these need to be part of the protocol. And then after you have decided this operational procedure, because a statistician may appreciate all this, because if you go on casual approach, our data might be questionable, and whatever we do it. Even I keep teaching my clinical collection students. Being a biostatistician, I may turn up to be a best manipulator. If you give me the sample size, if you talk about the behavior, a pattern of the disease, you can get one dissertation every day from me. But unfortunately, morality and ethical issue doesn't allow us. So what I'm trying to tell you, that the first we need to be morally very strong, ethically very strong, then research methodology comes in. Those who are having the practice of manipulation, this lecture on the research methodology has no value. I think I don't feel shy to say this. So first we have to be morally strong, and then only you will appreciate all these steps, how to plan it, how to make sure that our data collection methodology has involved everything. Who will collect data, how data will be collected, who will supervise, who will do the correction, who will make the data scrutiny, who will do the data, everything. Don't dump in the market. Somebody will do data entry for you after data collection. So issue here is we have to be very clear, and whole focus is on the accuracy of data till we have completed the data analysis. Because if you have collected accurate data, dump in the market, give some money, and you don't cross-check whether data entry is proper or is not, this is a big topic. 1 hour I can speak on the data management itself. But I'm trying to give you the take-home message that we need not to be casual while we are doing a study. So now, if our study has got the ethical clearance involvement, write complete protocol regardless of the study design, whether it is observational or whether it is randomized control trial, apply for the ethical clearance, and then once we get the institutional ethical clearance, then only we are supposed to start the study. And any change after getting the ethical clearance is discouraged, but if it is unavoidable, we need to report to the ethics committee. This is what the standard procedure we have to follow as a researcher. Now coming, I have been asked by Professor Srivastava to touch briefly on the analysis, exploratory analysis. I think we have to be very clear that the important message I would like to tell you, that for data analysis, any study we plan, there has to be a provision. 3 months, 6 months, 9 months, 1 year, depending on the size of the study, we need to incorporate in our protocol so that the funding people don't pressurize you to work in haste. And that provision, if you do it, and all these issues which is written in this slide, if you take care of, like basic issues generally forget, how to categorize the variable. Like I can quote you one example. Take smoking. There might be 3 possible measurement scale. Generally people, what you do, are you a smoker? Yes, no. Let us presume all other covariates are final and excellent. And if you include yes and no smoking, that will give you one epidemiological model. You can use the, if you are dealing with the coronary heart disease logistic regression, it will give you one regression model. But same data, if you change the scale of measurement of smoking, ever smoker, current smoker, and non-smoker at all, means 3 categories now. 2 dummy variable or categorical variable. Run again same regression model. You will get different result. Third is what? You have got complete data on smoking. since how long one is a smoker, on an average how much one is smoking. This is what in public health we call it problem density. And if you convert this data for every individual in terms of number of bundle of cigarettes or biddies, whatever you decide depending on the data, that will have much more meaning. Same way like breastfeeding. People make life simpler. Breastfeeding, yes and no. Breastfeeding partial, complete. Nobody takes pain to consider the more relevant categorization of these kind of variables. And if variables are questionable, they have questionable categorization. Whatever analytical method or statistical package we use, our results are going to be questionable, and whatever planning we do based on the questionable result, they will remain questionable. Simple message we have to understand: don't go in haste. Plan the study, deal with optimally, and then only you go on. So now, how to analyze the data? We have to always remind us what was our study objective, what study design we used it, what were the scale of measurement, and likewise we have to go on. Now, question here is, while going for the descriptive study, I think I am reaching to allotted time, and that is why I am just skipping quickly. I want to give you some more bases. In original form scale of measurement, we need to consider, like in computer era, every information becomes quantitative. Like we code it, gender, male and female, we code it 1 and 2. And generally, I have seen even today, until today, if you read the articles submitted from state medical colleges and interior colleges specifically, mean of the gender is reported. This is very unfortunate. And problem is we are ignorant that while analyzing the data, we don't know what was the scale of measurement. Because in computer era, this becomes quantitative. I have simply run descriptive statistics and we have reported the mean and standard deviation. It should never happen. What we can report in the dichotomous data, at the most you can talk about the frequency. Which category has got the highest frequency? Same way there is ordinal form of the data. Like you have got the disease status, healthy, mildly disease, moderately disease, severely disease. What is the difference between nominal and ordinal? We have to appreciate. The nominal means there is no order, but in ordinal there is a order, means increasing or decreasing level. And same way socioeconomic status, you can take the simplest example, low socioeconomic status, and likewise you go up to highest socioeconomic status. But what is the difference between ordinal and interval ratio? Quantitative data. Under quantitative data, you can take the difference between two measurements. Under ordinal scale, we cannot quantify the difference between two categories. If we really want to take the difference between healthy people and mildly disease, there is no way. This is what I wanted to tell you. So here you cannot run descriptive statistics, mean and standard deviation. What we can report? You can at the most, you can report mode, you can report the midpoint, means median categories, whatever you have got it, and different location measures. But in quantitative data, numerical data, you can report everything. Mean, median, mode, measure, sublocation like percentile, decile, quartile, quintile, whatever. Means anything you want to report, you can report this. So while analyzing the data, we need to take care of what is the scale of measurement for this particular variable, which I am going to analyze. Now, under this descriptive measure, in medical field specifically, I would like to speak on the weighted mean. Generally, we know it that if you have got different study groups having different sample size, we need to calculate weighted mean. But generally in medical data, we become ignorant. Like some data is coming from the laboratory. But problem is, here data becomes in terms of cells. So being a statistician, we have to be very clear. One particular blood sample, how many cells have been analyzed? And this is hypothetical data. Like you have got cytogenetic data. You have got the pathology department, cytology department, anatomy department, biotechnology department, and you have got the studies based on the cell-based. One blood sample, 250 cells have been analyzed. Another 200 cells have been analyzed. Another blood sample, 150 have been analyzed, and as low as 50. This 5 samples example I am taking. Now, the researcher will come to us and will say, sir, I am interested only in measuring the chromosomal aberration, for example. What percentage is their chromosomal aberration? And once you tell them, they will tell you this is a standard measure. And the instruments provides us whatever instrument we use to estimate this. But we need to understand biology. We have to discuss with them how exactly data is analyzed, data is collected and data is analyzed. Like simply, whether blood cells considered under each blood sample are same or not. Then only we will be able to know that the blood cells number is varying. In first blood sample, 150 have been analyzed, but fifth one only 50 have been analyzed. So if you apply usual arithmetic mean, percentage of collaboration will be 60%. Same way unexposed area, this is Bhopal. I think after I left Bhopal, this example I prepared out of that experience. And here, same way, if you take the unexposed area, percentage aberration will become 60%. And interpretation you will do that the toxic gas exposure has not made any change in the chromosomal aberration. But fact is what? We have analyzed data inappropriately. Inaccurate methodology we have used it. What is correct? You go for weighted mean because number of cells in each blood sample is changing. So correct calculation will give you what? 73.5% versus 46.7%, which is huge difference. And your interpretation will become that the toxic gas exposure among women or men have made significant change in the chromosomal aberration. So I think message is what? Even if you have done data collection appropriately, at the last stage, if you use the inappropriate statistical methodology, everything will go in vain. All our efforts will go. You might have spent crores of rupees in planning this study and conducting this study. Like these days, the genomics data, the microarray data is involving 5 crores, 10 crores, 30 crores. Like we have got cohort study, we have got almost more than 50 crore. By now we have spent 32 crore original and more additional money is coming. So issue here is, as a researcher, as a statistician, we have to play a tremendous role on our own rather than doing simple formalities. Somebody is coming without discussing, without understanding the data and the study design. You use the package, run the package, like our chief guest was telling that our chairman told that the blind use should be discouraged. Statisticians have to play a major role even up to the last scale. Now, another message I would like to tell you, any data we are analyzing, regardless of the nominal, ordinal or quantitative data, scale, whatever, the measures of dispersion have to be reported. Generally, I have seen many a time people only list mean and submit the research article. It should never happen. And why answer I will tell you based on this hypothetical data. If you take these 3 data sets, quantitative data, calculate mean, for each data set mean is same. For each data set median is same. For each data set, if you calculate mode for first is 120, another is 140, and then third one is 140. And if you calculate the standard deviation, first data set, every value is 120, variation is 0. If you calculate standard deviation, it becomes almost 20. If you calculate means, the data measures of averages or location might be same, but dispersion might be different. And whole theoretical statistics relies on what? Variance. In any introductory lecture, we speak on existence about the statistical approaches. If there is no variability, no need of a statistician, no need of statistics. Unfortunately, it is not going to happen. neither in the past, nor present, nor future. So we have to deal with the variance, and we have to be much more accurate to know about the present variance and use them wisely while analyzing the data to derive the inferences for the public health program. So now, depending on the scale of measurement, like quantitative, you go on this line. And here, I'm not going to add this because I hope I'm going to cross my time limit. Only here, I would like to tell you, whenever you have got more than 2 points of data, you need to use the analysis of variance. Either it is independent group or it is the repeated measures. And why do we need to go for this? Because if we use the unpaired t-test, even non-parametric Wilcoxon ransom test repeatedly between one group to second and one group to third and second group to third, what will happen? The level of significance will go up. And artificially, using the probability, multiplication rule of probability, if you apply on the confidence level, 0.95 into 0.95 into 0.95, you go on up to around 72, means level of significance becomes 28%. So we will know that we are analyzing data at 5% level of significance, but virtually we are analyzing data at 28%. Chance of getting significant result goes up. And the rule basis for us is always, whenever there is more than 2 group or more than 2 follow-ups, go for analysis of variance. Either it is one way or it is 2-way or repeated measure ANOVA. That is must. Either it is parametric or it is non-parametric test, critical values test or Friedman test. So this is one message I had to tell you. Under dichotomous, one thing I would like to emphasize, which is generally misused, study design. There are 2 study designs to collect the data by the PG students. One PG student is covering 1,000 patients coming to a particular OPD. Then he is collecting data on the smoking and disease status. That is one design. And another guide has suggested that you take 500 diseased and 500 non-diseased, and then collect the data on the smoker. Virtually, these are 2 design of data collection. And what is the misuse every time I keep noticing? For seeing analysis, what we use, generally in both cases, chi-square test will be used. Once you prepare the contingency table, chi-square test will be used. But chi-square test interpretation will be guided by the design of the data collection. Like in first case, we have not put any restriction on the data collection. We have covered 1,000 people and then collected data on disease status. Their null hypothesis becomes what? Whether disease is not associated with his smoking status. You can say that. But in the other case, we cannot say this because we have created artificial distribution that data has got 50% disease people. In the first case, it is not the scenario. Disease proportion might be 30%, 20%, or 40%, or 60%. So now here, what the hypothesis will be? Whether among disease and non-disease group, smoking is comparable or not. So in statistical language, what do we call it? Under first study design, we call it chi-square test for independence, and under design, other one is called as chi-square test for heterogeneity, homogeneity. So we have to be very clear. No clinician, no applied researcher goes in this way. Always they would like to interpret data in terms of association, like disease is associated with smoking. So I think this we need to discuss until unless we have collected data in that format. And another format, another outcome is time to event. Time doesn't allow. Only I would like to mention that that requires different approach. We need to go for the descriptive measures, survival analysis to the, you can go for the hazard modeling up to, you can go for the univariable to multivariable. So I think one can go using the same logic, how to proceed on that. So now, interpretation of the result, we have to be very clear. Could we get the question specific analysis? That should be first. If data could not be collected for our research question, we have to say sorry. We could not. Interpretation should be driven by the design of the study, the way I have just told you. Design has to guide interpretation. Method of data analysis might be same. Like if you take the cross-sectional study, you take the case control design, and you take the cohort design. Our design I'm taking, and you have taken simple disease status, yes, no. You will be applying logistic regression in every case, but interpretation will not be in the same direction. For the cross-sectional approach, we need to use the word association. For case control design, we can use the risk factor, and risk factor can be very well used under the cohort design because directionality between smoking and coronary heart disease you have taken into account. So this is how we have to take care of. Means message is interpretation need to be guided by your study design and evidence-based interpretation. First, we should talk about our result, and whatever we want to discuss, that we should put under discussion. Many a time I have seen under result, we start talking about others' result, or we start making a statement based on our perception. Then there is no research. So I think that we have to be very clear. So I think this is what I will. Yes, I think I will stop here. There are guidelines to report the every study design. These days we can use them properly after the end of the study, and we can prepare the report. I think this is what I have to tell you. This is concluding remarks. Statistics needs to be used as a tool in every step of research methodology. There is no doubt. Conceptualization of the topic to the interpretation of the data. Basic consideration like scale measurements guide almost every step. Study design is unavoidable from planning to interpretation. Statistical components need to be expressed in layman language. So I think this is all I have to stop. And if somebody wants to read, there are related books. These days, I think references are enough, plenty. One can read it.
Thank you very much, Professor Dwivedi, for your useful, valuable, and knowledgeable talk on the subject. You have taken examples from Bhopal gas leak tragedy. You have taken examples for explaining how a design be planned, how data be collected, how an experiment be designed, how a sample size be determined. Should not be based on the power of a test, it should be based on the confidence level. And so many things I cannot explain. So what we will do, we will upload your video lecture on the website of Dr. Bhimrao Ambedkar University, because though you have explained everything in 45-50 minutes, but it's so useful, so knowledgeable that people will listen to it very carefully again and again. So I cannot summarize, and I don't dare to summarize what you have spoke to us, what you have told to our audience. Your talk, I am sure, would help the research scientists to prepare research question and would frame hypothesis very carefully, select research design, and decide sample size for meeting the objective of the study. Thank you so much, Professor Dwivedi. Now, in the second,
thank you very much, my pleasure.
Technical. Now, in the second session, I would request my colleague, Professor Meenakshi Srivastav, to introduce our next speaker, Professor Vijay Kumar, a professor of statistics from Deen Dayal Upadhyay Gorakhpur University, Gorakhpur, a very eminent professor of statistics. Over to Professor Meenakshi Srivastav.
Manoj sir, Professor Vijay Kumar ji is offline now, so you can call next to the Professor Suresh Sharma sir at it.
Okay. Now, switching over to the third session, I will request my senior colleague, Professor Vinita Singh ji, to introduce our third speaker, Professor Suresh Kumar, Department of Statistics, from Punjab University, Chandigarh. This is over to Professor Vinita Singh ji. Ma'am, you are not audible.
मैम
Ma'am,
अनम्यूट
you
करिए
are
अपने
not
आप को
audible.
Yeah, not audible.
Thank you, Professor Manoj. A very good evening to all of you. We have with us Professor Suresh Kumar Sharma from Department of Statistics, Punjab University, Chandigarh. He is having experience of over 25 years in teaching and research. He works in the field of biostatistics, statistical modeling, distribution theory, statistical genetics, and bioinformatics. Having published more than 110 research papers, he has delivered more than 575 talks on both national and international level, and visited more than 30 countries, including USA, UK, Austria, Germany, etc. Under his guidance, 12 students have completed their PhDs and 4 are enrolled at present. He has various projects to his credit, which include project on professionalization of youth work in collaboration with Commonwealth Secretariat UK, and a project on public health and pollution control in Asia in collaboration with Health Effects Institute, Boston, USA. He has been working with WHO and ICMR on a few other projects related to environmental health profile, age-related macular degeneration, in collaboration with Department of Neuroscience and School of Public Health, Chandigarh. He has held various renowned positions. He was appointed as Chief Statistician of Global Harmony Project, Sweden and Russia. He has worked as Ambassador, Asian Council of Science Editors in 2016, and also appointed Advisor, International Medical Olympiad Association in Greece in the year 2017. He has received various awards, including Shiksha Ratna Award 2011, a Best Citizen of India Award 2012, Anil Mehrotra Award for the Best Paper in Drug Addiction, besides others. Professor Sharma has conducted several workshops on SPSS, Minitab, R, Stat Graphics, Statistica, Comprehensive Meta-Analysis, and Structural Equation Modeling. He has also written a book recently on medical sciences. We are honored to have Professor Suresh Kumar Sharma with us today. Now he will deliver a talk on SPSS. As we know, SPSS is a revolutionary software and has positively impacted the field of data analysis. Today, SPSS is used by market researchers, survey companies, government entities, education researchers, marketing organizations, data miners, and many more for processing and analyzing data. Now I invite Professor Suresh Kumar Sharma to deliver his talk on multivariate approach, data reduction techniques, multiple correspondence analysis and cluster analysis, confirmatory factor analysis, and multidimensional indices, data reduction using principal component analysis and discriminant analysis, strength and weaknesses of multidimensional data reduction techniques using SPSS software. We welcome you, Professor Sharma.
Thank you.
Before Professor Sharma starts his talk, I understand, we all understand that we are short of time. So it is up to Professor Sharma what topics he chooses. which could be very relevant for us would be factor analysis or whatever. I mean, it is his choice, but because time is too short and we have written a number of bullet points, a number of multivariate analysis procedures and techniques. So let's not expect not too much from him. So it is up to you to discuss the procedures, statistical procedures.
Should I start?
Sure.
So thanks for the invitation. I would like to thank Professor Ashok Mittal, Vice Chancellor, Dr. Bhimrao, Ambedkar University, Professor Diwakar Khare, Director, Institute of Social Sciences, Professor Manoj Srivastav, Convener, Professor T.C. Anand, who has delivered the inaugural talk, Professor S.N. Dwivedi, one of our good friends, Professor Vinita, Professor Meenakshi. So nice to be with you in the evening. I will be delivering a talk on multivariate techniques. And Professor Dwivedi has already covered some of the basics of statistics. So that has made my task easier. But I will focus on some multivariate techniques. It will be a capsule type of lecture for 50 minutes. And it will include most of the topics of statistics, but just a flavor, because I cannot do the real hand-on experience at the time is too short. Okay, how I can share my desktop, please? Is there any, somebody can help me?
1, 2,
How
3,
I can
4.
share my desktop?
This is 4, 5 number at the top. There is an icon share a screen on the right corner of the top of your screen.
Okay.
Right corner, sir.
Show your screen.
1, 2, 3, 4.
Yes, sir. Please
4
click on that.
Which one?
Your
This is,
screen share, sir. Share.
Your screen is visible.
So your screen is shared.
show screen.
Yes, sir. Just minimize that. Just minimize.
Okay.
Just minimize this screen, sir. Go to minimize, sir.
Just minimize.
Go to top right corner. There is a minimization button. Just press that.
I am looking for that only.
Yes, yes, yes. The cross one, then there is a full screen and there is a minimize screen. The third option, sir. Top right corner of your
Which one? This one?
type right. Type
Change
right.
projector.
This cross and then full screen and then minimize the screen. Just minimize the screen, sir. Just
No.
Sir, you open your
Go to
file,
the
it
doc-
will automatically minimize. You open your
Okay.
file, sir.
Okay, to open a file.
So go to start. You can minimize. There is a cross button. Are you looking at a cross button, sir? Cross
This one. This one.
in the top.
This one.
Top. Yes, sir. Yes, sir.
This one.
Cross. Then go to the left one, sir. Cross.
It says we
then full
leave webinar.
minimize the screen.
No, sir. Leave webinar.
It
No,
says
no.
leave webinar.
Okay, no, don't touch sir. Don't touch this, sir. Don't touch this.
Which one?
सर स्क्रीन के ऊपर चले जाइए बिल्कुल सर राइट कॉर्नर में जाइए
जी।
राइट कॉर्नर में ऊपर जाइए वहां पर एक क्रॉस का बटन है उसके बाद फुल स्क्रीन है और उसके लेफ्ट में एक मिनिमाइज का बटन है सर थोड़ा ऊपर जाइए सर थोड़ा और ऊपर
ये वाला?
और
ये वाला?
और नॉट दिस
Yes, sir. Yes, sir.
यस सर
Yes, sir. Yes.
कर्सर इज नॉट मूविंग show my screen
Show my screen.
Yes, yes. अभी सर आपने जो क्रॉस किया था इसके पास दो और बटन है एक मैक्सिमाइज का एक मिनिमाइज का है जो बिल्कुल छोटा है उसको आप प्रेस कर दीजिए मिनिमाइज हो जाएगी आपकी स्क्रीन
this one
It says waiting for the next screen. The message is like this.
अब जो नीचे टाइम आ रहा है टाइम के जस्ट राइट में क्लिक कर दीजिए प्लीज
अपने
जो नीचे
पे
टाइम
time
आ रहा है उसके राइट में क्लिक कर
राइट में
दीजिए
जाइए एक क्रॉस का
सबसे
बटन मत
नीचे
दबाइए
जो
उसके बिल में
ये वाला
कुछ एक्सेस बने हैं, उसे मत दबाइए, उसके बगल में बहुत छोटा सा
यहाँ
डैश
पे
बटन
लिखा हुआ क्लोज दिस पेन. What is this? Choose a screen or application to show. Is that okay?
So you want your desktop screen, na?
Yes, I want my desktop screen. I want my
Sir,
desktop
just
actually,
click
so
on-
that I can.
सर जो नीचे जहाँ पे टाइम और डेट लिखा है उसके राइट में क्लिक कर दीजिए प्लीज.
कहाँ पे टाइम और डेट है? मुझे तो दिखाई नहीं दे रहा है.
सर सबसे नीचे बिल्कुल नीचे
यहाँ पे
राइट
गो
कॉर्नर
टू
में.
वेबिनार जहाँ लिखा है, जहाँ पे गो टू वेबिनार लिखा है, सबसे नीचे तो वही है.
सर टॉप राइट कॉर्नर बिलो लाइक राइट कॉर्नर.
स्टेटस बार में नीचे आ जाइए, जहाँ टाइम और आपका इंटरनेट का सिंबल आता है.
सबसे नीचे सर, राइट कॉर्नर
इससे
सबसे
नीचे?
नीचे, राइट कॉर्नर पर सबसे नीचे वाला कॉर्नर राइट का.
क्लोज दिस पेन लिखा हुआ है लाइट.
राइट में जाइए सर, डोंट गो देयर. अपनी स्क्रीन के सर बिल्कुल बॉटम में आइए.
मैं इसको मिनिमाइज करके अगर अपनी स्क्रीन की
right में
सीधा
जाइए.
खोल लूं, कैन यू सी दैट?
हाँ यस सर, मिनिमाइज कर दीजिए सर. जी सर,
आपको ये दिखाई दे रहा है?
अभी वो दिख रहा है सर, अलाउ गो वेबिनार टू लॉन्च.
नहीं, मैंने तो अब अपना पीपीटी खोल दिया अभी.
ओके,
Can you
आपकी
see that?
पीपीटी खुल गई?
हाँ, मैंने खोल दिया.
तो हम लोगों को नहीं दिख रहा, आपने
मैं
शेयर
आपको
नहीं किया.
दोबारा से प्रेजेंटर बना रहा हूँ सर, अब दोबारा से एक
तो
बार
आपने
अलाउ
शेयर
करिएगा
नहीं
प्लीज.
किया, शेयर कर दीजिए.
तो आप कह रहे हैं ना टाइम और वो, यहाँ तो कुछ नहीं आ रहा ना जी. ये प्रेजेंटर आप आ रहे हैं, नमन गर्ग.
मैं सर चेंज
जी,
कर रहा हूँ
अब दोबारा.
एक सेकंड. जी सर, बिल्कुल सर, अभी आपकी पीपीटी शो हो रही है.
हो रही है?
जी
जी सर.
हाँ, इसको क्रॉस कर देते हैं फिर इसको.
इस पर
जी, अब ये पीपीटी दिखाई दे रहा है आपको?
दे रहा है सर, दिखाई दे
हेलो.
रहा है, दिखाई दे रहा है.
ओके.
हाँ सर, दिखाई दे रहा, बिल्कुल आ गई, दिखाई दे रही है.
Okay, I will start with a 50 minutes presentation, only 50 minutes, and that will give you an overview of multivariate techniques. I will start from very basics and try to build up the things as the lecture goes on. Look at the nature and types of data. I am audible to all? No?
Yes sir, yes sir.
I am audible? Okay.
Yes sir.
Look at the nature and types of data. If you look at the nature of the any type of data is either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one which can be put into numeric form. For example, height, weight, blood pressure, cholesterol. And what is an unstructured data? Unstructured data is the one which is not in the numeric form, but with these certain statistical techniques, you can convert this into numeric form. For example, everybody using WhatsApp. There are thousands of SMSs every day. There is a video, there is a picture, there is a text message. Now, if the end of the day, I ask each and everyone to convert this into numeric form, I don't think it is easy. So that kind of data is called basically unstructured data. So what is the basic difference between structured? Structured is in the numeric form and unstructured is not in the numeric form. And it's easier to deal with structured data, very difficult to deal with unstructured data. Now, what happens sometimes? The data is not exactly in the numeric form, but you can easily convert this into numeric. For example, gender. Now, gender is not numeric as such. It's male and female. But I can always assign certain code. Let's say male as 1, female as 2. So it gets converted into numeric. Similarly, religion. I can write Hindu as 1, Muslim as 2, or you can write Sikh as 1, Muslim as 2. Hindu doesn't make any difference. So what comes under structured data? Either it is already in the numeric form, or it can be easily convertible into numeric form. That comes under structured data. As I already explained, unstructured data is not easily convertible into numeric form. Now, as far as this seminar is concerned, I will focus only on structured data. Structured data means which is in the numeric form. To analyze the unstructured data, we need some advanced techniques like Dirichlet's integral, machine learning, artificial intelligence. So all these techniques are required, sport vector machine, to go for the analysis of the unstructured data. That is beyond the scope of this seminar. So if you look at the structured data, any type of structured data is basically of two types. Either it is called categorical data or it's called a measurement data. Now, what do you mean by categorical data? Already examples like gender, you can write 1 and 2, or religion, you can write 1, 2, 3, 4, or you can write socioeconomic class like lower class, middle class, upper class, you can write 1, 2, 3. So categorical data is the one where the measurements can be put in terms of categories. And what is a measurement data? Measurement data is the one where some kind of instrument is being involved in measuring something, for example, height, weight, etc. Okay. Now, if you look at the measurement scales, there are 4 measurement scales, 2 associated for the categorical data and 2 associated with the measurement data. This part has already been covered by Professor S.N. Dwivedi. I'll not focus much on this. And 2 scales which are there for the categorical data are nominal and ordinal. What do you mean by nominal? As simple as that, if there is an equal weightage to each and every category, then we say that our data belongs to the nominal scale. For example, gender. Gender, everybody is human being. So I can write male as 1, female as 2, or you can write female as 1, male as 2, doesn't make any difference. Similarly, religion. Religion, you can say put into nominal scale because every category is having equal weightage. But what is the difference between nominal and ordinal? In case of ordinal, the categories can be arranged either in ascending or descending order of magnitude. For example, socioeconomic class, lower class, middle class, upper class, it becomes ordinal because you can arrange the categories in order. Similarly, education classes can be arranged in order: primary school, middle school, high school, and so on. So these are the 2 important scales for categorical data. And there are 2 scales for measurement data also. One is called the interval scale, another is called the ratio scale. Now, in interval scale and ratio scale, people get generally confused. Actually, in interval scale, mathematical operations sometimes are not valid. For example, if you look at, let's say, somebody has scored 90 marks in a test. Another student has scored 30 marks in a test. If I divide 90 by 30, the answer will be 3. But I cannot generalize the statement that the student having scored 90 is exactly 3 times the intelligent than the student having scored 30. It doesn't make any sense. Similarly, let's say some beauty contest is going on and there are judges giving, say, score out of 10. Suppose first person gets a score of 8 and second one gets a score of 4. If I divide 8 by 4, answer will be 2. But you cannot make a statement that the person having scored 8 is exactly twice the beautiful than the person having scored 4. It doesn't make any sense. And to overcome all such difficulties, there is a highest rating scale, and that is called the ratio scale. So in interval scale, basically, if you are still confused with interval and ratio, in interval scale, 0 means actually it is an undefined event. It is not defined at all. For example, if I say age 0, it doesn't have any meaning. Height 0, it doesn't have any meaning. But it has a meaning in ratio. For example, if I say, let's say temperature 0. So temperature 0 has a meaning. So if 0 has a meaning for you, your data will go to the interval scale. If 0 does not have the meaning, it will go to the ratio scale. And in ratio scale, all the mathematical operations are valid. For example, let's say somebody is age of 45 years. Another person is 15 years. So if I divide 40, 15, so answer will be 3. So I can always make a statement that this person is 3 times the age of this person. Nothing wrong with that. So only thing which you have to remember between interval and ratio is that in interval scale, there is 0 is an arbitrary 0. For example, if I say somebody has scored 0 in a test, it doesn't mean the person is not intelligent. If I say temperature 0, it does not mean the temperature is absent. There the 0 has a meaning. While in ratio, 0 is actually the true 0. So with this background, actually we require to analyze the multivariate data. So first of all, we have to see whether our multivariate data involves the categorical data or it involves the measurement data. Then the techniques have to be derived accordingly. Okay. Now there are some basic techniques which have already been discussed. I'll not go into details. Like for descriptive statistics, we compute mean, median, mode, quartiles, deciles, percentiles, etc. Then there are many probability distributions which solve problems like binomial, Poisson, normal, exponential, etc. Then there are different type of correlations which we study in our 10+2 class or even in undergraduate students, Karl Pearson's correlation coefficient, Spearman's rank correlation coefficient. gamma or partial type of correlation coefficient. But if you look at the different varieties of correlation coefficient, you see generally we use this Karl-Pearson's correlation coefficient when both y and x, they are measurable quantities, number one, and moreover they have to be normally distributed most of the time. But if your data is present in the form of a rank, let's say one variable is on a 5-point scale, another variable is also on a 5-point scale, and you want to compute the correlation between the two, so Karl-Pearson correlation coefficient will not work because the data is in ranking. So we use Spearman's rank correlation coefficient. Then there is a multiple correlation coefficient. What is a multiple correlation coefficient? Multiple correlation coefficient means there is one dependent variable and there are a number of independent variables. If you have such type of scenario, then use multiple correlation. For example, yield of a crop. Yield of a crop depends upon type of fertilizer used, type of seed used, or the amount of irrigation and so on. So it depends upon multiple factors. So if it depends upon multiple factors, then we use multiple correlation coefficient. And what is a partial correlation coefficient? Partial correlation coefficient is again a correlation between two variables, but by controlling the effect of the other variables. For example, somebody may be looking into the relationship between age and blood pressure, right? Age and blood pressure. But in your data, there may be smokers and non-smokers. And if you are exactly looking at the correlation between age and blood pressure, it can reflect the correlation that it is very high correlation, while there could indirect effect of smoking also. And generally, clinically also tested that those who are smokers, they are likely to have high blood pressure as compared to those who are non-smokers. So in such type of situations, if there is some indirect variable, then we have to control that before looking into the actual relationship between two variables. That type of correlation is basically called partial correlation. And if you have a type of relationship, points are not along a straight line, just like for Karl-Pearson's or Spearman's, we need a points along a straight line. If it is not, if points are along a curve, then we compute generally correlation ratio. And if there is no specific which is not observable, then sometimes we need to compute the non-linear type of correlation, for which we need advanced statistical techniques like generalized LT models and so on. Okay. So these are not only the type of correlations. As I mentioned that for different scales, there are different correlations. But unfortunately, most of the statistics people, what they do whenever there is a categorical data, they go for chi-square. But chi-square, you see, it's a square. It can never be negative. You cannot say whether it is negatively related or positively related, because chi-square value is always positive. So there are, I listed in this slide, there are two important correlations which are given in many of the statistical packages. For example, if your one variable is nominal, another is nominal. The example could be, let's say somebody is looking at the relationship between, let's say, gender and blood groups. Blood is nominal, blood groups are also nominal. So what are the different type of correlations which are available? So we need to compute contingency coefficient, phi or Kramer's lambda or uncertainty coefficient. Out of this, uncertainty coefficient will give you negative and positive value. So you will come to know in which direction the correlation is moving. Similarly, if you have ordinal by ordinal data, then generally people compute gamma coefficient, and it could be negative, it could be positive. If you compute simply chi-square, it will always be positive. And if you have nominal, one variable is nominal, another is in interval, then you have different type of correlation, kappa, risk, McNemar, eta, biserial correlations. So there are different type of correlations to be computed. Okay, some of the examples. I think I will share this slide with Professor Srivastava, and this can be put into the website so that anybody can see the examples, because time is too short and I don't have time to explain all the examples where to use which one. But if you go through the examples, you will clearly come to know where to use which type of correlation. Okay. Now, major problem comes while analyzing the data in statistics is to check the normality of the data. Now, how to check the normality of the data? Many of the students or researchers, they are not very clear. Basically, there are three graphical procedures. One of the graphical procedures is called histogram. You look at the shape of the histogram. If the shape of the histogram is more or less symmetrical, then we say that our data is almost normal. Or you look at the box and whisker plot. In box and whisker plot, there is a median line. If median line is there in the center, of the box, where box is plotted between first and third quartile. If median is there in the center, then we say that our data is normally distributed. But the best way to look at the graphical representation to check the normality of the data is called the QQ plot, or generally called the normal quantile plot. And there are exact methods also. But here is a caution: we use exact methods only if you are in a fix whether I should take this as normal by using graphical procedures. Let me tell you, graphical procedures are more powerful than the exact procedures like Kolmogorov-Seminar test or Spiro-Wilk statistics. So they are all available in many of the statistical packages. So I'll give you just a slide to check the normality of the data. Just look at this slide. So if you look at the histogram, you see there is a big bar and there are only 3 bars on the left hand side, but there are more bars on the right hand side. And if I drop a line from the biggest bar, then only three bars on the left and more bars on the right hand side. And this is actually the normal curve. So your data is, if your data would have been normal, all the bars, they should have been within this curve, but it is not in our case. That means I can say that data is not exactly normally distributed. And more bars on the right hand side, it also gives the idea that it is positively skewed. Then if you look at this kind of data, if you draw a line, it's almost symmetrical. So we can say that it is almost symmetrical. And sometimes when you are in a fix of this kind of situation, whether I should take this as normal, not to take this as normal, then we generally apply the test like Spiro-Wilk test or KS test, etc. Then we apply those. Okay. And another way to check the normality of the data is by using this, you can say, this is called the box plot. The lower end of this box is placed at Q1. Q1 is called the first quartile. The upper end is placed at Q3. And then there is a median. And this is the same data actually. This is the age data for histogram and age data, same age data, where the range is from 18 to 63. And this is for the box plot. So if you look at the shape of the median is not there in the center. Again, if you drop a line, I mean, you drop a curve will go like this. So if you tilt this to 90 degree, you can see that again it is positively skewed. So if the simple idea is, if the lower area of the box is smaller and upper area of the box is larger, then we say that our data is positively skewed. Now, the basic idea of plotting box plot is that it can identify outliers. Now here the age range is between 18 to 63, as you can see. Suppose I change one observation. Suppose I change observation, one of the observation was 47. And I deliberately by this observation as 147. And this observation was changed to 147, one observation. And again, look at the box plot. So if you look at the box plot again, so it will identify that 12 number observation is an outlier. To identify outliers. So that's why there is an importance of box plot. And this is a quantile plot. For the same age data, you can see some deviation. These are basically quantiles of your data. These are normal quantiles. So if your data would have been normal, all the points, they should be along a straight line, but it is not. That means there are deviations. So it clearly says that data is not normally distributed. So with the help of graphical system, we can see whether our data is normal or not. Now, next question comes, whenever we are dealing with large data sets, let's say in my data set, there are 50 variables. Now, if there are 50 variables, I should check the normality of each and every variable and also find out the outliers are there. But there is a multivariate technique to find out. You can look at the Mahana-Lobis distance. And this is the formula of the Mahana-Lobis distance. And for demonstration purpose, I have taken only 2 variables, variable 2. And this is, if it crosses a certain threshold point, then it is considered as an outlier. So you can find the outlier even in a multivariate data. Okay, now Professor Dwivedi has given you some idea about hypothesis. Now, as we know that there are parametric and non-parametric tests. I will not go into parametric and non-parametric test, but where to apply parametric test and where to apply non-parametric test. That will be the idea. Now we apply parametric test only when our data is distributed normally, or you can easily transform your data by using certain transformation to a normal form. Now, how to check the normality of the data? Either using histogram, box plot, quantile plot, you can check, or you can apply tests like Spirovilk or KS test. Then, if your data satisfies the assumption of normality, independence, then we use parametric test. And the most commonly used parametric tests are Z-test or T-test. Generally, Z-tests are used for large samples and T-tests are used for small samples. But your T-test approaches to Z statistics whenever your sample size becomes very large. So in most of the statistical packages like SPSS, there is no Z-test actually, because T-test can be used for small sample. It can also be used for large samples. So only T-test is given in SPSS. But anyhow, which kind of hypothesis can be tested using parametric tests like single sample T-test, difference of two groups, paired data, correlation coefficient, and there are other, like, let's say, why not to test two variances? If there are two populations, why not to test two variances? Whether two variances are equal or they are unequal, one can use F statistics. And if there is one-way alpha variance, two-way alpha variance, again F statistics is used. And then there also it comes under parametric test, one-way ANOVA, two-way ANOVA. So all this requires assumption of normality. So basic idea of parametric test is that our data must satisfy the assumption of normality, independence, constant variance, etc. If they are intact for our data set, then we apply parametric test. Otherwise, we have to apply non-parametric test. These are some of the non-parametric tests which are available in most of the statistical packages. Now, what is the basic difference in testing, actually, parametric and non-parametric? You see, in parametric test, we always test the population parameters, and generally population parameters are mean, variance, proportion. These are population parameters. But as far as non-parametric tests are concerned, we are concerned with medians. So most of the non-parametric tests, they are concerned with median. We can test a hypothetical median, we can test difference of two groups in medians, or if there are more groups to be tested, we can apply Kruskal-Wallis test, Friedman test. So all these tests are available as far as non-parametric tests are concerned. What the key point is, you remember whether our data satisfies the assumption of normality. If it does, go for parametric test. If it doesn't, go for non-parametric test. Okay. Now, many of these statistical models are there. Now, what kind of models we can discuss? You see, I may be a little bit fast because this is not my topic. I'll come to my topic maybe for 15-20 minutes and give you an overview where to apply factor analysis, where to apply cluster analysis, and MANOVA and ANCOVA. So please be sure that you stay tuned for next 30 minutes, please. So generally, if you have only two variables, let's say one variable is dependent, another is independent, we go for a simple linear regression analysis, where there is a relationship between independent and, for example, somebody may be interested to find out the estimated weight for a given height. So we can go for simple linear regression, provided the points are along a straight line. So you y and x points are along a straight line, you can go for simple linear regression analysis. And we go for a multi-regression analysis when there is one dependent variable and it depends upon number of factors. For example, IQ. IQ may depend upon mental age, it may depend upon, let's say, anxiety, it may depend upon depression, it may depend upon number of factors. And you want to estimate IQ based on all these. So Y is your IQ and X1, X2, Xk may be anxiety, depression, and other things. So whenever such type of situation is there, then we use multiple regression. And be sure that if you are carrying out a multiple regression coefficient, multiple regression analysis, then there could be certain problems like multicollinearity. What do you mean by multicollinearity? That means if independent variables like X1, X2, Xk, they are related to each other, then there is a problem with multiple regression in carrying out multiple regression, and that problem is called multicollinearity. So if there is a multicollinearity in your data, then we have to look for variation inflation factor, we have to look for tolerance, and if they are beyond certain limits, then we can go for ridge regression, we can go for standardized regression technique rather than simple multiple regression techniques. Then there is a problem of heterostochasticity. And if there is a problem of heterostochasticity, then again we have different kind of models. Then there is a problem of autocorrelation. Autocorrelation means error terms are correlated. Generally, this happens with time series data, and we have different type of problems to solve. You can go for Darby-Waston test of statistics to check whether the autocorrelation is there or not. So next question comes, whenever we are going for a multiple regression type of problem, can we include dummy variables in the model? Some of the people say that no, it is not possible to include dummy variables in multiple regression model. Answer is actually incorrect. We can include dummy variables in the model, but we need to create dummy variables actually, dummy variables. So if there are, let's say, male and female, we need to create one dummy variable. If there are 3 categories, we need to create 2 dummy variables. And then there are certain techniques. With the help of that, we can see how much change is there from one category to another. So we can include dummy variables in the model. Then there are many other type of regression. Logistic regression is generally used for categorical data. Then there is a mixture of categorical data and measurement data. Logit model, probit model, they also work on the same principle. Panel data regression is there. If you are having, let's say, a different type of variables, let's say 1950 to 1960, then you have same set of variables. They are studied between 61 to 70. Then another time period is there. Then for that type of data set, we use panel data regression. And there are non-linear regressions. So there are plenty of regression techniques which are available in statistics. And all these techniques are available in most of the softwares, R, MATLAB, Minitab. So all these things are. And there are certain econometric models also. For example, autoregressive model, moving average process, and autoregressive and moving average. And then SRIMA model, ARIMA model. So all these are models, different models which are used in econometrics. Okay. Now with this background, as I mentioned that I have taken maybe 20 minutes, I'll come to the 2 important techniques today. In fact, 3 important techniques today. One is called factor analysis. Another is called cluster analysis. And then I'll go for ANCOVA, and if time will permit, I'll also touch upon MANOVA. Okay. Professor Manoj, am I audible to all this time now?
Sir,
just check. Audible now? And yes, we can see the screen, right?
We can see the screen, and you are very much audible.
Okay. Okay. So I will first of all discuss what do we mean by factor analysis. So please, now I'll take a little bit more time because earlier part was actually has to be discussed by the previous professor, and he could not be, he was offline. So I have to cover that part, in fact. But anyhow, so let me look at the factor analysis. I'll not go into much of the details of factor analysis because time is too short, but to give you some idea where to use factor analysis. Basically, a factor analysis is a data reduction technique. And in regression analysis, there is a concept of independence and dependent variables. But as far as factor analysis technique is concerned, there is no concept of dependent and independent variables. Number 1. Number 2, factor analysis technique is applicable only when most of the variables are correlated. Let me just repeat. Factor analysis technique is applicable whenever most of the variables are correlated among themselves, because we have to reduce the data, and data reduction is possible only when there is correlation between the variables. So that, let's say, if there are 2 variables, x1 and x2, correlation between 2 variables is 0.9 or 0.98. So maybe one of them can serve the purpose rather than 2 variables. So that's why this factor analysis techniques works. And there is a principle which is called PSA, principal component analysis. I'll discuss this in detail. So basically remember that factor analysis is a data reduction technique. It reduces the dimensionality of your data, and it is applicable wherever there is correlation among variables. And the third point is there is no concept of independence and dependence variables. So I'll take very simple example and try to demonstrate how to carry out factor analysis. Okay. This is the special example I have taken because many of the people, they go to the mall, right? Now, whenever they go to the mall, they look at many things: cleanliness, entertainment, parking space, games for children, different kinds of brands available, food court, whether plenty of food courts are available or not. So now let's say owner of the mall hire a team of researchers and give this task that I want to optimize my mall facilities. Can you suggest something on certain parameters so that I can improve upon? And this team of researchers design a questionnaire. And included, let's say, 15 variables which are related to cleanliness. Cleanliness of toilets, cleanliness of floor, cleanliness of lift. So all the 15 variables are concerned with cleanliness. Then there are certain variables, 20 variables, next 20 variables, and I call this as V1 to up to V15. Then there are certain variables which are related to entertainment, whether they are showing English movies, Hindi movies, or movies from other languages, right? So all these concerned like entertainment, they are having around 20 variables. So in all and all, now we have 15 plus 20, 35 variables. Then there are certain variables, 15 variables, next 15 variables, they are concerned with parking space, right? Enough facilities for parking, whether parking is at reasonable rates or not, whether it is hourly rate is not so much, and so many things you can record on a 5-point scale, 7-point scale. So there are 15 variables. Then there are game section also. People take their children for various games, they drive cars, they go for computer games and so on. So there are 25 variables concerning with, let's say, children. And there are different brands also they are looking for, whether Levi's is available, whether Peter England is available. So they also go for brands. Let's say 25 variables you include for brands. And then there is a food code, whether Sagar Ratna is there, whether McDonald's is there, whether others are there. So 20 variables related to food code, right? So in all and all, if you see how many variables we have in our questionnaire, you have 120. Now question here is with you. Do you think that all the 120 will be important? Not necessary. Not necessary. Maybe you have included certain questions which may not be of importance. So what is a factor analysis technique? Factor analysis, as I mentioned, it's a dimension reduction technique. It reduces the entire dimensionality of 120 to certain important factors. And those factors explain maximum variation present in your data. And that's why we apply this factor analysis technique. Now, how these factors are extracted? Actually, these factors are extracted based on a principle which is called the principal component analysis. What is a principal component analysis? It's basically looking into, let's say, first factor. Let me go through the next slide. It will give you some idea. Now, suppose these are your variables. If you can see this slide, our variables are there. I put in V1, V2, V20. Suppose these are X1, X2, Xk up to X20, X120. These are 120. So it will extract first factor. If I put I is equal to 1, so it will extract factor number 1 with certain linear combination of variables. Linear combination of variables may be some variables may involve from cleanliness, some variables may involve from entertainment. It may happen, right? And let's say 8 variables from, let's say, cleanliness and entertainment, they are included in F1. They are included in F1, only 8 variables. And let's say your F1 variable explains 45 variation present in your data. So only 8 variables, which are the part of F1, are basically explaining 45% variation present in the data, right? Okay, then another factor is being extracted, which is again a linear combination of the rest of the variables, mostly rest of the variables. That means out of the 120, it will leave most of the time these 8 variables and focus on 112 and extract another linear combination, which can explain next maximum variation present in the data. And that is called F2. Let's say F2 explains 30% variation present in the data. So your F1 explains 45% variation present in the data. F2 explains 35% variation present in the data. And both of them together, let's say it explains 80% of your data. So these two factors explain 80% of your data. But please remember, those variables, they are there in F1, will not be in F2. That means F1 will be uncorrelated with F2. There may be some kind of overlapping, but if you apply a principle which is called Varimax method, generally it is a orthogonal rotation, and whenever there is a orthogonal rotation, overlapping doesn't happen. right? Most of the time. Only in few cases it may, if your data set is very large. Similarly, other factors can be extracted. So let's say rest of the variables now there are, and suppose third factor, which is F3, that explains say 15% of the variation. So first factor explains 45% of the variation, which is F1. F2 explains 35% of the variation, and F3 explains, and let's say 15 variation. So in all and all, F1, F2, F3, they explains 95% variation present in the data. That means, and you have included only now, let's say in F1 there are 8 variables, in F2 there are 11 variables, so in all and 19, and in F3 there are 6 variables. So you have only 25 variables. So your 25 variables out of the list of 120 has explained how much percentage of the variation of your data? 95%. Then why to include rest of the variables? That they are explaining just 5% of the variation of your data. So we can exclude them. And this dimensional reduction in terms of factors is basically called factor analysis. So I think it makes sense if you go through this, out of this 120 variables, maybe you can select only 25 to 30 variables which are of most important, and they can explain, let's say 90 to 95% variation present in your data, and that may be important for you, right? And they are extracted with the help of a principal component technique. So there are certain statistics which we need to understand. For example, whenever we deal with the matrix, there is a concept of eigenvalues. Now, only those factors are important for you where the eigenvalue is more than 1. Let me just repeat. So whenever you carry out the analysis of factor analysis, it will look into the eigenvalue of factor 1, factor 2, factor 3. Only those factors will be important for you where the eigenvalue is more than 1. If for any factor eigenvalue is less than 1, you have to drop that factor. It is not important for you. And not only that, if you have, let's say 8 variables under factor 1, so it will tell you that which variable is most important, which is the next important. So it will find out these weightages, weight, these are weights, W's are weights. So it will give you that under this factor, these variables are most important. Similarly, under F2, these variables are most important. Under F3, these variables are more important. Hopefully, I am able to explain the crux of factor analysis by taking up this example. Is it clear, Professor Manoj?
Absolutely,
Hello.
sir. Absolutely.
Okay. Now, if you permit me, I can run the factor analysis and show the participants how the factor analysis work through SPSS. Is it possible? So
Sure,
I can
sure.
open a data set. If there will be a data screen, you can just let me know. And then I will run the analysis and show it to you how the factor analysis can work. I'm just opening the factor analysis slide, and those who are interested how to run the factor analysis, what you need to tick. It's a very heavy file. Let me open it through. Yeah, it's opening. Just a minute. Can we see this slide, please?
Yes.
It may take few seconds. Is
No,
it coming
it's
through?
visible. It's visible.
Okay, it's visible.
But,
Okay.
SPSS data file is visible to us.
Yeah. Okay. Very good. So this is the very small data set just for demonstration purpose. Otherwise, generally factor analysis technique is applicable whenever we deal with very large data sets. Now, the experiment is like this. I'll explain you the experiment so that you can understand the technique of factor analysis. Let's say if you go through the variables, this is a 7-point scale. The variables are measured on 7-point scale. What are these variables? Now, whenever people go to the market, they want to buy toothpaste. And if they want to buy toothpaste, they look at many things. Now, one of the things is they want to buy that paste which prevents cavities. That's a variable number 1, right? And they want to buy that paste which gives shining tooth. That is variable number 2. So it is being rated from 1 to 7. Let's say person say it is number 1 for me. Number 1 means the least priority goes to the cavities protection. And if it says 7, the highest priority goes to the prevention of cavities. Similarly, shining teeth, then there is strengthening of gums, there is a freshness of breath, there is a tooth benefit offered by toothpaste, and for attractive teeth. So all these 6 variables are there, and I want to apply this factor analysis technique on this. So I will carry out the factor analysis and give you the analysis. What is the actually, so that you can understand, rather than going into the theoretical part, because theoretical part will take more time and it's very difficult to look into the problem. Okay. Now, what are the steps? Maybe somebody can note down the steps. What are the steps in SPSS? Go to analysis. If you go to analysis, then as I mentioned that it is a data reduction technique, and data reduction is a factor. That's a factor analysis. Hopefully we can see the screen and go to factor. As I mentioned, now this window will open. Professor Manoj, can we see this window?
Sure, sir.
Okay, very good.
Your step and procedure is looked by us.
Okay, now you can see there are variables. This is V1, V2, V3, all these variables are there. So there is no concept of independent and dependent variables. So what I need to do, let's say Control A and shift all these variables to this side. So shift all the variables to this side. There is no independent and dependent variables. Then variable here, selection variable. Let's say I divide the, I am interested only in male data or female data. So you can go for a particular selection variable. That I'll not go into details, but anyhow, now what we need to do, actually go to descriptives. Now in descriptives, you go to univariate descriptives, click onto this. Initial solution is already there. Then you look at the correlation coefficients, you look at the significance levels, and you look at KMO and Bartlett. Please remember, first of all, we need to check whether our factor analysis technique is applicable to our data or not. So there are two important tests. One of the tests is called Bartlett test of specificity. But what is a Bartlett test of specificity? Basically, it will test whether the variables are correlated or not. So I will put the hypothesis that the variables are uncorrelated, and the alternative will be variables are correlated. So I need correlated variables for factor analysis. So I need to reject H0. So I need this value to be significant. So please remember, Bartlett test value has to be significant. Number one. Number two is a KMO test. It's a test of sampling adequacy, whether your sample size is appropriate or not for your data, right? And this KMO test value has to be between 0.5 to 1. If it is less than 0.5, do not apply factor analysis. Please do not apply factor analysis technique. It is not applicable to your data. Let me just repeat two tests. There are two important tests. One is Bartlett test. Bartlett test has to be significant. And then KMO value has to be between 0.5 to 1. If these two are intact, that the Bartlett test is significant, KMO value is 0.7 or 0.8 or maybe 0.6, you can go for factor analysis, right? And then you also click on to reproduced. Now, after doing this, you press continue. And then you come to the extraction principle. As I mentioned, that we need to extract factors F1, F2, and they are based on a principle which is called principal component analysis. So go to extraction now. And by default, the extraction method is principal component analysis. So we will not have to change this. During my biodata, when Professor Vinita was reading, somebody, she was also saying that he will cover confirmatory factor analysis. Actually, whenever there is a confirmatory factor analysis, we use this principal axis factorization method, generally for CFA. But here I am covering only EFA. EFA is called explanatory factor analysis. Then we have to look for the scree plot. Now, what is a scree plot? Scree plot is nothing but the factors along x-axis and the eigenvalues along y-axis. And you have to see which eigenvalues are more than one. So you will see how many factors are extracted, as simple as that. And then press continue here. And is a rotation, because we need what is called the type of rotation which is at 90 degree, so that F1 should not correlate with F2, F2 should not correlate with F3, and F1 should not correlate with F3. So all these correlations has to be very, very minimal. So there is a method which is called, which is based on a principle of orthogonality, and that is called Varimax method. So this is the best method, Varimax method. Click onto this, then loading plots you need to click, and then continue. And finally, you have to get these scores. Scores save as variable. So by using regression method and display factor score coefficient matrix, press continue. And last thing which we need is in option, which is very important, please. Let's say if you have certain variables values which are missing, so you can use this option, replace with mean. Although I will not advise, but if your data is almost normal, you can use this option. Otherwise, now to look at the importance that if under F1, these are the variables, under F2, these are the variables, what is the hierarchy of variables? Whether it is important, which one is most important, which one is next important. You always sort it by size. And suppress those values which are very, very small. Let's say 0.3. So because correlation of less than 0.3, you don't want actually. So that's it. So if you follow these steps, your factor analysis is complete. So I'm just going to click OK, show you the result, and then we'll go for cluster analysis. Okay. So here is the analysis. Analysis has been done, performed it is, just taking time. Can we see the output, Dr. Manoj?
Sure. Yes.
Can we see the output now?
Yes, it is visible
Okay.
on the screen, sir.
Okay, very good. So this is the output. Now you can see first is a mean SD table. There are 30 observations, so we'll not have to do anything with mean SD table. Then there is a correlation matrix. As I mentioned that it is a technique where correlations are important. So in fact, we will not have to see this correlation. We have to see KMO and Bartlett. That is the most important part. So I will straight away, we see this correlation is very high. This correlation is very high. This correlation is very high. So some of the correlations are very high. That means variables are correlated. It makes sense. So this is the most important, whether I can go for factor analysis or not. So first is the KMO. This is called Kaiser-Meyer-Olkin test. Now what is the value here? 0.660. And as I mentioned that KMO test value has to be between 0.5 to 1 and our value is 0.6, right? Second is Bartlett test of specificity. This value has to be significant. And now you can see this P value is less than 0.05. So it is significant. So this is significant. So both the tests are valid. That means I can go for factor analysis. Okay. So I have applied factor analysis and this commonality. There is one term in factor analysis which is called commonality. You will not have to explain much about this, but let me explain you the meaning of commonality. Commonality means how much variation one variable shares with the rest of the variation, where the rest of the variables is called commonality. For example, if you look at variable number 1, it shares 92.6% of the variation with the rest of the 5 variables. This is what it means. So how much variation is shared by that particular variable with the rest of the variables is called commonality, basically. Now, these are the factor extracted. So you will be clear from this that these are eigenvalues. And we have to extract only those factors where eigenvalue is more than 1. Now look at the, please in many of the statistical softwares, factor is also called a component. Factor is also called a latent variable, right? So don't get confused. Component, latent variable, or a factor, they're all synonymous. So whether it is a component or a factor, let's look at factor number 1, which is component number 1. Its eigenvalue is 2 point something, and it explains how much percentage of the variation, 45.5%. Okay. Next is factor component number 2. It is again more than 1, 2.6, and this explains 36%. And both of them together is here. That means both factors explain almost 82.5% of the variation present in the data. That means rest of the variables, they are explaining just the rest of the 17% of the variation. And to look at more diagrammatically, you can look at the scree plot. So if you look at the scree plot, these are eigenvalues, these are component. And if you drop a line from here, you can see only 2 factors are having eigenvalue more than 1. So only 2 factors can be extracted. But if you look at other factors, this eigenvalue is less than 1, this is less than 1, less than 1, less than 1. So I'll not extract these factors. So that means only 2 factors are extracted, which makes sense for this data. And what are these 2 factors? And they don't look for this type of component matrix. Always look for repeated component matrix, because we have applied Varimax rotation. This is a very confusing, go for a rotated component matrix. So here is a rotated component matrix. So this one, this is a rotated component matrix, and it will give you the clear idea which variable is most important, which is the next one, which is the next one, right? Okay. For example, our first variable was the two factors have been extracted. So these are the variables under factor number 1. These are the variables under factor number 2. Let's see what are these variables. So first was, I want to buy toothpaste that prevent cavities. So its weight is the, people have rated this the maximum. Its weight is 0.96. Weight will be between 0 and 1. Don't go for negative and positive sign in factor analysis. Always look at the absolute value. Even if it is minus 0.9, it's having the same strength as 0.9, right? But this is, since we have sorted by size, so variable 1 under factor 1 is the most important. Next is not variable number 2, it's variable 3, that I want to buy toothpaste which should strengthen gums. And then next is variable number 5, tooth decay benefit offered by the toothpaste. That is, these two are having very high weightages. This is put under factor number 1, which is called component 1. And the next of the 3 variables are put under factor number 2. But let's see what is the nature. Nature is, I want to buy toothpaste for attractive teeth. So he's not looking for from the health benefit. He's looking from social benefit angle. Freshness of breath, again from social benefit angle. Shining tooth, shining teeth, again from social benefit factor. See, factor analysis doesn't give you the name like factor 1 or factor 2. If it extract the factors, you have to assign the name yourself. For example, if you look at these, all the variables are concerned with health. So you can name this variable, this factor as health benefit factor. Similarly, you can name this as a social benefit factor, cosmetic benefit factor, whatever you name want to assign. And if somebody asks you that, you tell me only 2 variables which are important, one from the cosmetic point of view, one from the health point of view. So you will say you buy toothpaste which should prevent cavities, and also that should give you attractive teeth. That means variable number 6, variable number 1. These are 2 important factors for you. If somebody say I need 4, so you can take first 2 from here, next 2 from here, right? So this is the entire technique of factor analysis. Now F1, there is no overlapping. See, F1 is uncorrelated with F2. And if you look at the conceptual map, this is the conceptual map. So if you look at the odd numbers are V1, V3, V5. They are under factor 1. Even numbers, by luckily, they are just by chance. Even numbers like V6, V4, V2, they are in another factor. And the plot is also like this. These are even numbers, these are odd numbers. So this is component number 1, this is component number 2, and there is no correlation. Now question is, where are these components now? These components are here. If you go through the data, I have saved these components. So this is your factor 1, this is your factor 2, and they have to be uncorrelated. So if I compute the correlation between F1 and F2, and you will see the correlation between them, let's say I compute Karl-Pearson correlation between them, and Karl-Pearson correlation coefficient this, and it has to be almost 0. And now this is a correlation matrix. This is the correlation matrix of F1 and F2, and you can say the correlation is 0. So that means these factors are uncorrelated with each other. So that is the technique of factor analysis. Hopefully it makes sense to you. And this is my presentation. You can go through the presentation later on and go through the details of this. What are the commonalities? What are there in the factors? So I'll just have given you the demo actually, rather than going for the theoretical part. So this is the presentation. You can read this carefully. These are the 2 important tests, KMO and Bartlett. This is commonality, eigenvalue, factor loading, correlation matrix. So scree plot is there, and this is the same picture which I have obtained. Hopefully the factor analysis is clear. Yes, please.
Sure.
Yes, sir.
Thank you.
If you have time, I can go for cluster analysis. Maybe MANOVA and ANCOMA. I don't think it will be possible to cover. Should I go for cluster analysis?
Sure, sir.
Yes, please. Okay. Let me go for cluster analysis. So factor analysis is over. I'll also give you demo for cluster analysis, and later on you can go through the entire description of cluster analysis. And I will suggest you a book also, where to read this factor analysis and cluster analysis in the last part of my. Okay, now if you look at cluster analysis is nothing but how to make cluster out of the given data. What is a cluster? Cluster, that means it's based on similarity index. That items which are very similar to each other, they are put into one cluster, and those who are dissimilar, they are put into another cluster. Those who are maximum dissimilarities, they are put into another cluster. This is how we call this as a clustering technique. I'll give you a very simple example. Whenever the students are attending a class and after the bell rings, the students disperse. And you must have seen that 5-6 girls, they move to one side, 3-4 students, they move to another side, 2-3 students move to another side. What does this mean? That means they are moving generally in a cluster. That means, what does this mean? That means they are having a similar habit. They are very well known to each other. That's why they are moving in the clusters, actually. So cluster analysis technique is basically looking into how many clusters out of the data can be formed, so that you can, for example, in mall, many customers goes, and you want to identify customers who are brand specific. You want to identify customers who are more concerned about cleanliness. You want to identify clusters or customers who are more specific towards, let's say, entertainment. And you want to find out all these clusters. For that purpose, we use generally the cluster analysis technique. It is also very useful in medical sciences. And I'll just explain you the cluster analysis technique, not through, but by demo, actually. So cluster analysis is a class of techniques used to classify objects or places into relatively homogeneous groups called clusters. And the objects which are in one cluster, they have to be similar, and they will differ from the another cluster. So you can go through this presentation later on. Now, can you see this picture, sir? Can you see this picture?
Yes, sir.
Okay. This is a very ideal situation. Generally doesn't happen in real life situation. See, there is a quality variable, there is a price. So if you look at this cluster is low on quality, but high on price. But if you look at this one, this is medium on quality as well as medium on price. But if you look at this cluster, then this is high on quality as well as high on price, while this one is high on quality but low on price, right? So very simple to make clusters out of such type of data if observations are given. But the situation is not ideal. Situation will be like this. This is a practical situation which we have to face. Now, how many clusters can be formed out of this data? And today I'll give you a practical demo how many clusters can be formed out of this data, right? So this is a practical situation. It's difficult to find out how many clusters could be there, right? So I'll give you a practical demo how the clusters can be formed out of this data. Okay. Now there are two types of clustering techniques. Basically, there are many types of clustering techniques, but today I will discuss only one type of clustering technique is called hierarchical clustering. Another type of technique is called non-hierarchical clustering. Non-hierarchical clustering is also called k-means clustering. Now, this hierarchical clustering technique is based on a proper schedule, and that is called agglomerative schedule or agglomeration schedule. It is based on that technique. You will not have to go into details of this. You can read later on, but it's better to give you the demo. And there will be cluster centroid. What happens actually? Let me see. Suppose there are data available to you. So it will first of all look into the Euclidean distance. Euclidean distance is a mathematical principle. Basically, it will look into squared Euclidean distance, and it will find out that which two observations are very close to each other. Obviously, those observations will be closer, where the distance will be very less, right? So it combines those two. I will tell you the technique. It will combine these two. Then find out a centroid that is called the cluster centroid of both these items. For example, one item is there, second item, you take the mean of, add the two and divide by, you will get a center. Then from the center, it sees which observation is closer now to the center. If it is very close to now, out of the rest of the observation, it combined into that cluster. And it principle goes on like this. And whenever it crosses a certain threshold, it crosses a certain threshold. Up to that point, all the items are clustered into that particular cluster, and after that, it will go to the next cluster. And same principle followed for the next cluster, and you will get the total number of clusters which are present in the data. So there are different techniques of cluster analysis, but today I will discuss only hierarchical and non-hierarchical. Problem with hierarchical clustering is you have to define how many clusters you require. Generally, we don't know. So that's why, first of all, we get the rough idea about the number of clusters, and there is a very important technique which is called dendrogram. I will show you how to plot the dendrogram. You look at the shape of the dendrogram and look at the gaps, and you can identify how many clusters are there. And then you go for non-hierarchical clustering, and there you put approximate number of clusters, and it will give you the idea that these are the approximate number of clusters can be formed out of the data. And it will tell you that these are the customers, they belong to this cluster, these are the customers, they belong to this, these are the customers, they belong to the third cluster, and so on. So that is the idea of clustering. Okay. So there are certain statistics. One of them is dendrogram. So I will consider this data set, additional data set for attitudinal data set for clustering, and show you how to make clusters. So straight away, I will go to the demo part and show you the clustering process. Will that be okay, sir? If I go to straight away to the clustering process?
Sure, sir. Sure.
Okay. I'll go to the demo because it's difficult to go through all these slides. Of course, these are the procedures available here. Maybe somebody is interested to look into, and these are clustering procedures, hierarchical, non-hierarchical clustering. They are based on different techniques, but we will not have to tell you a very simple technique how to form clusters and how to go about it. So I'll open a data set and show it to you. Let me close the first data set of factor analysis and open the cluster analysis data set. So I'll open a data set. Okay. Sir, can we see this slide?
Yes, sir. Yes, sir.
Okay. I'll show you the nature of the variables. See, there are about 20 customers are there. They are going to a mall, and we want to identify that which customers are similar, which others are similar, which others are similar. We want to form clusters out of this data, right? So let's look at the variables. If you look at the labels, first is simply a case number. So we'll not have to do anything with this. There are maybe 20, 30 people. First, whenever they go to the market, they have been asked to rate on a 7-point scale. That shopping is fun. For some people, shopping is fun. If it is fun, they will write 7. If it is not, they will write 1, right? Then shopping is bad for budget. I think husbands should be asked whether shopping is bad for budget or not. Okay. So again, it is on 1 to 7-point scale. I combine shopping with eating. Whenever people go for a shopping, they also go for eating, right? So I want to get the best buys while shopping. I don't care about shopping. You can save a lot of money by comparing prices. So all these variables are included on a 7-point scale. So these are the variables. Now we will make clusters out of this data, right? Now how to make clusters? So please see, if data is with you, you can note down the steps how to make clusters. Go to analysis, and in analysis, you go to classify, because it's a classification technique. We need to classify. First of all, go for hierarchical clustering. Don't go for k-means clustering. K-means clustering is also called non-hierarchical clustering. So first of all, go for hierarchical clustering, right? Please remember the steps. Go for hierarchical clustering. Now, which are our variables? Our variables are shopping. First is a case number. We'll not have to bother about case number and take all these variables to this side. Again, in cluster analysis also, there is no concept of dependent and independent variables, just like in factor analysis, right? Then in statistics, what we need to click. Now, you see in hierarchical clustering, it is asking how many clusters you need. We don't know. We don't know how many clusters we need. So best way is to go for, just press continue here and go for plots. And in plots, you click this, what is called dendrogram. And if you click this dendrogram, you will come to know about the approximate number of clusters. And based on that approximate number of clusters, it will be very easy task to go for the non-hierarchical clustering, where there it will ask you how many clusters you require actually. Continue. Then methods. Now there are many methods here. As I mentioned, I have shown you a slide. Many methods are there, but I'll show you that which one is the best one. First of all, cluster method, the walls method is best. The last one. The walls method is best because it is based on smaller variance principle. I mean, cluster, the items which are in the same cluster, they will be having very, very small variation. And that is captured by Walls method. So I'll be using Walls method, and it is based on a principle which is called scared Euclidean distance. That's it. So use the scared Euclidean distance and Walls method, continue. Then save. Nothing have to be saved here because we don't know how many clusters will be there. That's it. So our aim for going for hierarchical clustering is to get the number, how many rough idea about the number of clusters. How many clusters can be formed. Okay. Just press OK. So if you press OK, you will see an important table. And in important table, sir, can we see this output now?
Sure, yes, sir. Yes, sir. It is
Okay.
seen. The
Now
output
you
is
see,
seen on the window.
please try to
Output
remember
is
how
seen
to
on the
read this
window.
output. Yes, please.
Yes.
Is it visible now?
It is visible in the output window.
Okay, that's it. That's good. So you see, there is a cluster number 1, cluster number 2, and there is a coefficient. Actually, coefficient in this table is nothing but distance. You see, it will look into which two items are to be having minimum distance. For example, look at the stage 1. There is one item number 14 and item number 16. That means customer number 14, customer number 16. They are very similar, and their distance is minimum. This is the distance. Then don't go for this type of table. Go for the next stage, please. How to read this table is very important. Now, what is our next stage? Next stage says 6. That you go to step number 6. That means first of all, item number 14 and 16 will be combined, and then it will go to the step number 6. And you look at step number 6. If you look at step number 6, out of 14 and 16, one of them will appear. Which one is appearing? 14 is appearing. And the next item that will be combined with 14 will be 10. You can see. And then you look at the next. Next is 9. And then straight away go to 9. And in 9, either 10 or 14 will appear. Now you can see 10 is appearing. And the next item will be 4. So this is how it combines actually. This is how to go through this table. So what we able to see, that first 14, 16, then 10, and then 4. These will be combined, and it will continue like this. The best way is to go for, rather than this table, this is a dendrogram. This is a dendrogram. So if you look at the shape of the dendrogram, if you remember 14, 16, 10, 4, next one will be 19 actually. The next one will be 18. So if you look at the shape of this dendrogram, you look for the gaps. How many roughly clusters can be there? So there is one gap here, you see. If you look at a distance of 5, so one gap is here, another gap is here, right? So there are 2 gaps. So one cluster will be this, another cluster will be this, roughly another cluster will be this. So you can make an interpretation that there will be basically 3 clusters out of this data. Now you, from the dendrogram, you are able to form a rough idea how many clusters are there. So basically 3 clusters are there out of your data. Now, keeping this as such, we will go for again for the analysis. So here is the cluster analysis, and I'll go for analysis again. And in analysis, go for classify. And in classify, now do not go for hierarchical clustering. With the help of hierarchical clustering, we are able to get the number of clusters. We're looking at the dendrogram, right? And please remember, there is one step also, which is called 2-step cluster. I'll not explain you today what do you mean by 2-step cluster, but this to be used only if your dendrogram picture is very confusing. You are unable to find how many clusters are there. Sometimes you have a very big data, then you can go for 2-step clustering. It will automatically form clusters out of your data, right? But now go for k-means clustering. Please remember, first go for hierarchical clustering. From dendrogram, find the approximate number of clusters. Now, approximate number of clusters are 3. Now I have to go for k-means clusters. What do you mean by k-means actually? K means, that means there are 3 clusters. K is 3. Actually, this means k is 3. So go for this. And now take all the variables onto this side. Again, variables. Label cases by case number. Now it is asking number of clusters. So we are able to identify how many clusters are there. So 3 clusters, you put 3 clusters are there, right? And then save the cluster membership, that which item goes to which cluster. It will tell you. Continue. And in options, you can click on to ANOVA table, although it is not required, but continue. That's it. So your analysis part is over and you press OK. And if you press OK, now you can see the cluster analysis part. These are the 3 clusters which have been formed. 1, 2, 3. These are cluster centers. And you see 6 items have gone to cluster number 1, 6 have gone to cluster number 2, and 8 have gone to cluster number 3. Now, which customer has gone to which cluster? You can, it is already saved because we have saved in our data. You go to the data set. For example, customer number 1. Customer number 1 goes to cluster number 3. Customer number 2 goes to cluster number 2. Again, customer number 3 goes to cluster number 3, and so on. So we are able to identify that which customer goes to which type of cluster. If you look at the frequency of this, so you can look at the frequency of this variable, and you will find again the same table, that 6 have gone to cluster 1, 6 have gone to this, and 6 have gone to this. So that is the idea of cluster analysis. So I think I have explained factor analysis, cluster analysis, some part of correlation and regression. I don't think we have a time because third speaker may be waiting. ANOVA and Mankova, they are still left. If the organizer will permit, I can just have a little bit of idea in 5 to 10 minutes. Otherwise, I'll stop. Yes, please, sir.
Yes, sir. The Professor Vijay Kumar Ji is not able to connect with us because of certain technical reasons.
Okay, so I can continue for another 10 minutes to complete?
Yeah, you can continue for 10 minutes, sir.
Okay, so please be patient. I'll be discussing a very, very important technique. These techniques are not, these techniques are in fact be taught only by experts, let me tell you. And even if you are applying the technique of ANCOVA and MANOVA, always consult the statistician because there are certain assumptions need to be checked. So I think the cluster analysis, factor analysis technique is over. Now I will come to the last part of my presentation, and that will be a very important part, where to apply ANOVA and MANCOVA. Okay. Where to apply ANCOVA and MANOVA. I'm just closing this. I'll share this presentation with you. So it's a dendrogram, all these things are there. And just to continue from here. Okay. Now I'll cover basically only 2 topics, ANCOVA and MANOVA. MANCOVA is just a part of MANOVA, so you will not have to bother about this. Now, please remember, while discussing the parametric test, whenever we are interested in comparing 2 groups and our data is follow the assumption of normality, and in order to compare 2 groups, we apply t-test, right? But suppose there are 3 groups, there are 4 groups, there are 5 groups. You cannot apply t-test unless you compare 1 versus 3, 1 versus 5. But there every time you are including 5% error. So if there are 3 comparisons, you are including 15% error. You cannot afford. Professor Dwivedi has already explained that if you multiply, go on multiplying, error will go on adding, right? So that's why we apply ANOVA. So what is one-way and two-way ANOVA? First of all, because you have to just link up one-way and two-way ANOVA with ANCOVA, and then you will be through. See, first of all, you need to understand what is analysis of variance. So if you go through this slide, analysis of variance is a technique which partition the total variation present among the set of observation into number of components. Obviously, if you are given a data set, there will be variation present in your data. And what is the ANOVA technique? It actually split your total variation present in the data into between variation, within variation, or between blocks, within columns, rows, etc. So it's that kind of technique. Now, I'll give you a very simple example of one way, then two way, and then we'll proceed without any demo of one way and two way. Just try to understand. Whenever we go to a market to buy, let's say, bulbs, tube or bulbs, so we want to buy that brand which is having the maximum life length or the minimum life length. So if we are intelligent enough, I think we want to buy that brand which is having the maximum life length, right? Now, I frame this hypothesis. This is Yij. Yij is called the life length. Let's say I take 10 tubes from Philips, put them on test, and note down their life length. Then I take 12 tubes from Bajaj, put them on test, note down their life length. And then take, let's say, 15 tubes from Crompton, put them on test, note down their life length. And again, from, let's say, some other brand, I take another set of 10 tubes, put them on test, and note down their life length. So I'm observing life length of brands. Now, question is, if the life length of all the brands is same on an average, if the mean life length of all the brands is same, I frame the hypothesis that alpha 1 is equal to alpha 2 is equal to alpha k. That means life length of all the k brands is same. Against the alternative, that there may be differences. There may be differences. Okay. Now, by applying certain technique, let's say I accept this hypothesis that life length of all the brands is same. Then you are safe. Go to market, buy any brand. Go to market and buy any brand because life length of all the brands is same. The problem comes when I reject the hypothesis. When you reject the hypothesis, next question comes. Number one, which brand is best? Which brand is second best? Which brand is third best? How you can make comparisons. And further, we need to apply what is called post hoc test. So we apply post hoc test in one way analysis of variance and see which brands differ from each other, right? So this, whenever we are comparing more than two groups, we apply one way analysis of variance. So in one way analysis of variance, basically we are looking into variation among between. So this kind of data will be there. These are brands. This is brand number 1, brand number 2, brand number K. And let's say I take one number of tubes from brand number 1, the life length, and 2 number of tubes from brand number 2, and K number of brands, and these are total number of observations. So ANOVA split the total variation into between and within. So once you split the variation, basically you will get this type of table. So you will get between variation, within variation, and total variation. Total will be nothing but sum of between and within. And we are having, if we are comparing K groups, degrees of freedom between will be K minus 1, total will be N minus 1, where N will be equal to N1 plus N2 plus Nk, right? And you subtract this minus this, you will get N minus K. Then it will compute mean sum of squares, you will get F value, and just look at the P value of F. If your F value, P value is less than 0.05, the result is significant. If the result is significant, go for post hoc analysis. If the result is non-significant, stop. Because all the brand you buy, go to market, buy any brand. That is one way ANOVA. So in one way ANOVA, only we have variation between brands, because there is only between brands. We are taking only brands. Now then comes two-way ANOVA. So this is two-way ANOVA. Now you see in two-way ANOVA, one more factor is added. Here it was only alpha, here beta J also. So we are testing two hypotheses. Alpha 1, alpha 2, effect of alphas, effect of betas actually. So I'll give you a simple example of two-way ANOVA so that you can understand. Let's look at yield of a crop. Suppose there is a yield of a crop. This is Y11. This is the first plot. And these are levels of, let's say, fertilizer. P levels of fertilizer. This is fertilizer F1 or A1. This is F2 or FP. And these are type of seeds. Type of seed B1, type of seed B2, type of seed BQ. So obviously this plot, which is observation is Y11, receiving fertilizer number 1 and seed number 1. But what about this thing? This is actually given fertilizer number 2 and seed number 1. And this is how the observations are actually. So your outcome, which is Yij, is affected by 2 factors. Number 1, the effect of seeds. Second, effect of brands. So there are brands, generally they are written as rows and columns, or levels of A and levels of B. So in this case, there will be 3 types of split up. So variation will be between A levels, between B levels. These are levels of A, these are levels of B. And now you compare them and you will get 2 F1 value. This F1 and F2. This F1 will test first hypothesis, F2 will test second hypothesis. So this is called two-way ANOVA. So in one-way ANOVA, the outcome is affected only by one variable. In two-way ANOVA, outcome is affected by 2 variables, type of seed, type of fertilizer. Now, this is all about one-way and two-way. I'll not go into details, but I'll touch upon ANCOVA now and give you a practical demo. So what is ANCOVA? Now, I'll tell you a very simple example of ANCOVA, and then I'll come to the demo part. Okay, let's say people are suffering from cancer, and there are 3 types of chemotherapies which are available for the treatment of. I call this as chemotherapy number 1, let's say K1, chemotherapy number 2, K2, and chemotherapy number K3. And all the chemotherapies, they are meant for the same purpose. Now I select one group of patients, give them chemotherapy number 1. Select second group of patients, give them chemotherapy number 2. And select third group of patients, give them chemotherapy number 3. Right? Now these 3 groups are receiving 3 different treatments. I want to test that the effect of all the chemotherapy is same. So basically, I am testing that H0 alpha 1 is equal to alpha 2 is alpha 3. Right? And what is the response variable? Response variable, you can look into the recovery time. How much response recovery in recovery time, that these patients recover in this much period. If you take chemotherapy 1, they recover. So your Yij is recovery time. So your outcome is recovery, right? So you have observations for one group of patients, you have observation for second group of patients. So it's one-way ANOVA, right? Now, in order to compare, you can apply one-way ANOVA. And you are getting nice results. There is a significant difference between chemotherapies. But whenever you are presenting a result, some of the doctor may be sitting over there and he may ask you a question. Have you looked into the age groups also? Now, it is quite possible that in group number 1, there may be younger age patients. In group number age patient, in group number 3, there may be older age patients. And you are looking at the effect of chemotherapies, treatments, that means. Now, obviously, those who are younger patients suffering from cancer, they are likely to respond better as compared to those who are older patients. So you cannot compare basically. So there is one factor which is making an indirect impact, and that is called age. So if you are simply applying one-way ANOVA, then you have missed the train actually, because age could be a very, very important variable. Professor Dwivedi was talking about covariate. So this is treated as a covariate. And the role of ANCOVA. And ANCOVA is called analysis of covariance. That means there will be one or maybe more than one covariate which can indirectly affect your outcome. So age can indirectly affect. So this is one of the example of ANCOVA. So for such type of problem, we use ANCOVA. And I'll not go for the demo. I think I'll show you the result. Now you know a little bit about SPSS. Let's look at this example. There is a anxiety assessment, which is on a, let's say, can be measured on a 5-point scale. And anxiety assessment, patient's anxiety of the patient is measured on 3 types of. One group was put on drugs, another was cognitive behavior therapy, and another was given no treatment. That means placebo, right? So you can simply apply ANOVA and get the result. But whenever you are presenting your results, some psychologist may be there, and he may ask you, are these patients for the similar type, or there were some depressed cases also? And you haven't looked into the depression. Now, depression can be considered as a covariate. And clinically, psychologists, people, they also know that depression and anxiety, they are correlated. And you haven't included the depression. And obviously, your results will be totally wrong. Let me show you these two results. If you apply simple ANOVA and if you apply ANOVA, what will be the final result? I'll show you only. So if you apply ANOVA, there may be a effect of it is an indirect variable which can affect the anxiety. And these are the three variables which you want to compare, three treatments. This is alpha 1, alpha 2, alpha 3. We can compare, but in the presence of a covariate, which is a depression. Okay. Now, what is the basic assumption to be tested? Let me explain you what is the basic assumption to be tested, and you will see whether we can apply ANOVA technique or not. If ANOVA technique is not applicable, go for ANOVA. That means depression cannot be considered as a covariate. Now, how it will check? It will check actually the interaction between this and factor. These are called factor, drug, CBT, these are treatment. So it will look into the covariate and factor. So this variable has to be non-significant. Interaction has to be non-significant. And if the interaction is non-significant, then and only then ANOVA technique will work. Let me just repeat. Interaction between covariate and factor has to be non-significant. So first of all, I'll check the interaction. So this star means interactions. Interaction between treatment, that is groups. There are three groups and depression. And this has to be non-significant. So here is a p-value. Suppose this p-value has to be, suppose it is coming out to be less than 0.05. Do not apply ANOVA, apply ANOVA. As simple as that. If it is non-significant, then and only then you apply ANOVA. Hopefully this makes sense to you. I'll give you a complete slide so that you can read later on. Okay, now if I am simply applying ANOVA to compare the three groups, you can see that if you apply ANOVA, degree of freedom is 2. Three groups we want to compare, CBT, drugs, and placebo. So result is coming out to be non-significant. So you can make the interpretation that there is no significant difference in the anxiety levels of drugs control and if you give CBT therapy, there is no significant difference. But you have made a mistake because there depression can play a role which you have completely ignored. Now if I include depression in next, you see depression, if I include depression, depression is coming out to be significant, and here what happens, the groups are also coming out to be significant. That means depression can be considered as a covariate. So this technique is basically called ANOVA. Hopefully this will make sense to you, right? And ANOVA is given under general linear model in SPSS. You can go there, and I will share one of my SPSS, how to learn SPSS. The link I will share with you. It is available through YouTube. You can go through YouTube video, put my name, Dr. Suresh Kumar Sharma, how to learn SPSS. You will see that video, link will be there. And there I have explained all these techniques, how to run one-way ANOVA, how to run two-way ANOVA, how to compute correlation regression, all these techniques are there. All right. Okay. So this is ANOVA. I'll not go into practical demo. Time is too short. The last question, MANOVA. Now, you see, so far, we have considered only one dependent variable, whether it was simple regression, multiple regression, one, two-way ANOVA, even ANOVA, there was one dependent variable. But in MANOVA, there may be more than one dependent variable. And the MANOVA technique is applicable whenever there are more than one dependent variable. Now, what are the conditions? Conditions are that if there are more than one dependent variables, then they have to be correlated. MANOVA technique is applicable only when the dependent variables are correlated among themselves. Otherwise, this technique is not applicable. I'll give you a practical example so that you can understand. You see, in India, we have basically three types of teaching systems after up to 10+2. One is CBSE board, another is ICSE, and the third is state level. Punjab State Board, UP State Board, they are conducting their exams separately. So there are three types of teaching systems: ICSE, CBSE, and let's say state level. So these are the three different methods. Now, students are being taught by these different methods. Suppose my interest is to look into that what is the, whether their performances by teaching these three are same or there is a difference. Let's say I select three major subjects. Let's say physics, mathematics, and let's say maybe biology. Let's say these are biology students. So I look into three subjects: physics, mathematics, and biology. Now these are three dependent variables. Now you can apply one-way ANOVA. How you can apply one-way ANOVA? Because there are three groups. One group is taught by CBSE, another is ICSE, third is state level, and you are taking the marks of physics, you compare one-way ANOVA. Then you take the marks of mathematics, you compare again by taking three groups, you can apply one-way ANOVA. Then take biology score. Now how many ANOVAs you have applied? Three ANOVAs, and in one ANOVA you are considering 5% error. So in all and all, there will be 5 plus 5 plus, so 15% error. So that's why those techniques are not applicable there. But you know that physics marks may be related to mathematics, mathematics may be related to biology. Chances are there if they are taught by one method, taught by another method. So these three are basically a dependent variable. So in one-way ANOVA or two-way ANOVA, we compare actually means, while in MANOVA we compare vectors. So there will be one vector of physics, mathematics, and biology for group number one. Another vector, another vector. So basically we want to compare these three vectors. And for that we use what is called MANOVA. Hopefully this makes sense to you. And here is the final result. I'll take one example and then stop. I think time is too. I'll take one example. Okay. This is an example of attitude organ donation. People donate organs like kidney or sometimes liver, right? So I think this is related to organ donation. How people behave when they donate organs. One is the attitude. The attitude is positive, they want to donate. Another is feeling about that they are emotional. Third is previous exposure to the issue. That organ donation, if you give one kidney, it doesn't make much of a difference. You can even stay without, even in one kidney you can stay. So these are basically three dependent variables, and they conceptually have to be correlated actually. So they have to be correlated, and we would like to take each of the dependent variables separately and conduct one-way ANOVA. You can conduct one-way ANOVA or t-test because there are only two groups, those who are on organ and those who are not on organ donation. You want to find out the difference between them. So you can use t-test separately, but their error will be more. So for that purpose, we can apply MANOVA. So if you apply MANOVA, let's see what is the result. So this is the result of MANOVA. There are 4 types of statistics which will be discussed. Now, whenever we get the output, one output is not shown here actually. One of the tests will be test for homogeneity. If the test for homogeneity is coming out to be that's significant, then you look at Wilks lambda. But if it is coming out to be non-significant, then you look at Pilet's trace. Now what we are doing actually, we are comparing 3 dependent variables, and there are one categorical factor. Categorical factor is whether the people opt for organ donation or do not opt for organ donation. We are comparing this thing, and now the result is coming out to be significant. So result is coming out to be significant in terms of variables. So let me explain you when to use Wilks lambda, when to use Pilet's trace. We use Wilks lambda only if the homogeneity test is coming out to be significant. There is a homogeneity test whenever we get the output. Unfortunately, it is not shown. If it is non-significant, use Pilet's trace. Sorry, if it is significant, use Pilet's trace. If it is non-significant, use Wilks lambda. Okay. So these are the statistics. And now further, if I want to see that which differ, then there it will automatically, MANOVA will give you automatically in terms of 3 variables. This is variable number 1, variable number 2, variable number 3. So these 2 variables, now you can see these 2, this is significant, but this one is non-significant. So if you apply MANOVA, in totality, all of them are coming out to be significant with respect to organ donation and non-organ donation. But if you see separately, only 2 of them are significant, but 1 of them is non-significant. So here is the final result, that attitude towards organ donation and feeling toward organ donation, they are coming out to be significant, and this is highly significant because its p-value is less as compared to others. So we can further go for Mankova. Now in Mankova, we can include age also. We can include depression score also, just like that as we have done for ANOVA. So these are some of the techniques for ANOVA and ANCOVA. I'll just take 2 minutes and show you. Just 1 minute, sir. There are many other statistical packages. One of them is MATLAB, Minitab, EpiInfo is called epidemiological information, stat graphics, SysTab plus BMDP is called biomedical data processing. Then there is for meta-analysis, there is two important packages. One is called CMA, comprehensive meta-analysis. I also do training on CMA, and another is review manager also for meta-analysis. But in comprehensive meta-analysis, you can perform meta-regression also. Here you cannot perform meta-regression in review manager. N-query is to compute the sample size. Then I also do workshops on R, RStudio, SPSS. Then there is Mathematica, Statistical, all these. And now those who are youngsters attending my class, I will encourage them to learn this. It's coming up now. Python is taking care of all these statistical softwares. It's easy to operate Python rather than any one of these softwares, and it's free. Now, some of the books, references. If you are looking for statistical modeling, go for this book by Bowerman and O'Connor. If you are looking for categorical data analysis, go for book by Ellen Agrasti. And if you go for parametric and non-parametric test, for non-parametric, very good book by Wayne W. Daniel, again for biostatistics, parametric as well as non-parametric, Wayne W. Daniel. And if you want to see cluster analysis, factor analysis, discriminant analysis, this is a very important book without much of the mathematics by Naresh K. Malhotra. He is an American marketing researcher. And if you are interested in statistics, I have written recently a book on medical statistics. This was launched by International Medical Olympiad last year in October from Greece. Medical statistics book by me, Suresh Kumar Sharma. So all these references are there. So thank you very much for your patience listening. Hopefully I have taken more of your time. Thank you very much.
Thank you very much, Professor Suresh Kumar Sharma ji. You have given us a very detailed description of not only of multivariate analysis. You have also introduced our audience. You have also introduced the linear models, non-linear models, curvilinear models, logistic regressions, with the help of lot of examples. As to continue up to, this was only for 2 hours, join us. So, and you have covered a lot of multivariate things, at least in the webinar, must have gained from your deliberations on multivariate analysis. We are very much thankful to you.
Maybe you can announce that if they are still not very clear about SPSS, because many of the people, they don't know SPSS, they can go through my YouTube video and learn SPSS. Actually, it's available freely.
There is an announcement to all the webinar participants. I will be sending the links, various links, and PPT and PDF and presentations, and also the link of Professor Suresh Kumar ji, where they can learn SPSS, how to learn SPSS. There is a link. And now I formally request the Director of the Institute of Social Sciences, Professor Diwakar Khare ji, to say a vote of thanks. But before that, we would like to thank Professor Vijay Kumar ji, who could not join us, and we are very sorry because of certain technical reasons. He could not join the webinar. I request Professor Diwakar Khare ji to give vote of thanks.
Now I present vote of thanks. I am audible? आवाज क्लियर है?
Yes, yes. बिल्कुल क्लियर है.
Respected Vice Chancellor Professor Ashok Mittal ji, Chief Guest TCA Anant, Professor Manoj Kumar Srivastav, Head Department of Statistics and convener of this webinar, Co-conveners of webinar, Professor Meenakshi Srivastava, Professor Vinita Singh, eminent speakers, Professor Vijay Kumar, Gorakhpur University, Professor S.N. Dwivedi, AIMS, New Delhi, Professor Suresh Sharma, Punjab University, Chandigarh, Professor V.K. Saraswat, convener, technical support, and my dear participants present in this webinar. The webinar on data analysis and statistical computing is on the verge of end. Data analysis is an integral part of every field. Therefore, today's webinar is very useful for the experts working in different fields. The year 1920 is very, very significant for every scholar of statistics. The reason is that the world-renowned great statistician C.R. Rao is going to attain the age of 100 years in September 2020. C.R. Rao obtained his doctorate under the supervision of Sir R.A. Fisher. Father, come to express real thanks to all the academic personalities involved in this webinar. At the outset, I wish to convey my special thanks to Honorable Vice Chancellor. This is a favorite subject of our Vice Chancellor, Professor Ashok. His strong support and high motivation is really appreciable. Next, I would like to express my genuine thanks to the head department of statistics key speakers. Professor Manoj Kumar Srivastava is a very energetic person. He worked hard for the preparation of this webinar. His strategic planning of organization is excellent. I must express thanks to co-conveners Professor Meenakshi Srivastava and Professor Vinita Singh for their constant help and valuable advices in the organization of this webinar. I am thankful to Professor V.K. Saraswat for his technical support. He and his team remain active at every instant of time. Many, many thanks to our keynote speakers for delivering research-oriented addresses. Their lectures will definitely be very useful for the academics engaged in research on data analysis in different areas. A lot of thanks to all the friends who listened to the talks carefully. I am sure that these participants will properly make use of the academic talks in their advanced studies relating to the domain of data analysis and statistical computing. Thank you.
Thank you.
Thank you.
Good night to everybody. Thank you.
Can we end, sir?
So thank you very much, Professor V.K. Saraswat. This is
Thank
just
you.
because of you. This webinar could be conducted so successfully, and you have given us 2 hours extra from the allotted time. So we are very much thankful on behalf of everyone, Professor Saraswat. Thank you.
Thank you, sir. Thank you.